In the year 2000, Awqaf South Africa was pioneered as an institute of Awqaf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
T minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2. We have liftoff. Vehicle is pitching downrange.
And we have liftoff. A warm southern welcome to all of our grade 12 physics online workshop participants. A warm welcome to you. Goeiemorgen, good morning, namaste, sawubona. A warm welcome from Awqaf, South Africa, and Falaah for this physics session. We will be focusing on chemistry. We had a fun-filled and a very informative, a very fast-paced session yesterday at physics session that we did have. So today we're going to be taking it a notch down. We have heard you. We will try and make sure that we have a very good session to assist you, the grade 12 learners, for your physics examination session. My name is Hassanin Abdullah. I'm from Awqaf, South Africa, and we are a community-based organization. We do host grade 12 maths workshops. So for the first time, jointly, we're doing this with Falaah. This is part of Falaah's community outreach project to assist learners from schools that need some assistance in terms of their maths and their physics tuition. So for today's session, we have emailed all participants the worksheets that our facilitator will be focusing on. We have seen that in PDF format. And during the course of the day, we will reiterate this, and Khalid will be the continuity presenter, will also be sharing that links. You are most welcome. If you are joining the session, yes, this is the Awqaf SA Falaah physics online workshop for grade 12 learners. We will be focusing on chemistry. Please let us know in the comments from which city you are connecting to us from, and also let us know from which school you are connecting to us from. Let us vibe today, today, and let us have a two-way conversation. Please subscribe to our YouTube platform, share this video, and let us keep that comments flowing. We will now be calling on Mr. Wahid, who is an educator from Falaah, and he will be addressing us by way of introduction. If we can get Mr. Wahid on the call, and he'll be giving us by way of introduction in terms of Falaah's program. This is the physics bootcamp that we are hosting at Falaah in KwaZulu-Natal as part of a bootcamp to assist learners with the grade 12 participation. Assalamu alaikum, Wahid.
Walaikum
Thank you,
salam.
Shawn.
How are you, Hasnain?
Alhamdulillah.
Alhamdulillah. Assalamu alaikum. Good day to all of you learners. Look, on behalf of Al Falah College, I just wanted to warmly welcome all of our students joining us here in person and online on our live streaming platform. We really are excited to host this extra lesson program, especially as we live stream physics for the first time due to such a great demand for the subject. To all of our online learners, we are pleased to let you know that the question packs that Sir will be using will be available for download as soon as the session begins, so you can follow along and practice in real time. Once again, a really heartfelt thank you to our facilitator, Mr. Haribans, who has been teaching for many, many years. Since before I was born again, for 3 decades or so, Mr. Haribans has been using his vast experience, and it will also be invaluable today. We are truly grateful for his guidance. We also would like to extend our gratitude to Awqaf SA once again for making this initiative possible. Let us all, dear students, make the most of this opportunity. May Allah grant us all success in our studies and our exams. Jazakumullahu khairan.
Okay, so thank you to educator Wahid. Yes, he rightfully said Mr. Haribans is a session facilitator. He's going to be taking us through that session. He's got over 20 years of experience in physics. So rest assured that the session is going to be assisting you. To all our participants, we have emailed you the workbooks that Mr. Haribans will be basing his session on. It has been emailed to all participants, and we will be sharing this information to you. If you've just joined the session, a warm welcome to one and all. Yes, this is the Awqaf SA Falaah Grade 12 Physics Online Workshop. Please let us know in the comments. Keep the comments flowing. Let us know from which school you are connecting to us from which province. What did you think of the session yesterday? So without further delay, we're going to be calling on Mr. Haribans, and he's going to be taking us through the session. It's over to you, sir.
All right, thank you, sir, for that introduction. Welcome all, ladies and gentlemen, the audience in front of me, and our learners online. I hope our session can be profitable today and successful. I'm sure it will be with your input and my input as well. What we'll try and do today is firstly look at the chemistry paper 2 for the national paper, look at some questions. I have emailed the learners online the copies of the papers that I'll be looking at today. It's chemistry paper 2 in the morning, and roughly we're going to look at 15 minutes per question, right? And thereafter we're going to look at later on after 12 o'clock the picture on your screen, what you're looking at now, that paper is a physics paper 1, which is also going to be done until 3 o'clock. Without wasting any more time, let's look at our session. Right, what we're focusing on now is, ladies and gentlemen, Physical Science Paper 2, Grade 12, Chemistry, okay? And for the audience in front of me, it looks like this, okay? It's in your booklet. Now, a few of those pages are not there in your booklet, so some of the questions you'll have to take it down when I'm going through them, especially the level 3 and level 4 type of questions, right? There's one question there, there's another one here, right? And there's a graph kind of question thereafter, another graph kind of questions, question 5, and then this is the paper that I did yesterday. So that's your paper 2, and the original questionnaire of that is in front of us as we speak. So I'll just remove this staple and then we'll begin. The most important thing I think for us in the examinations, this is my personal choice. I prefer my students to do the multiple choice question first and get it over and done with, and then tackle question 2 to 10 after that. And if you are unsure, leave it empty and make sure you come back to finish the answer before the 3-hour time schedule is up. And that's my personal preference, because sometimes you'll find learners skip the multiple choice and do it at the end, but some of them forget to even do it and you've lost 20 marks. So the ideal way of doing it is to finish it as lesson question 1 and get it over and done with before you go to the rest. Zoom in more, okay? Is that a little better now? Audience?
Hello, guys. Is that better? Hello? Better.
Can I bring this thing forward? I see my page is hanging down, yeah? No, we have to go more back. More back. Okay, let's see. Let's see how it goes now. Right, question 2. Okay, 2.1. What is a functional group? Now, a functional group is a definition. Now, ladies and gentlemen, audience in front of me and online learners, I'm not going to try and write too much on level 1 definitions, because you have them in your textbooks and your guideline documents. You've got to learn them, but I will define them verbally. A functional group is an atom or a group of atoms that give organic molecules their chemical and physical properties, or determine their chemical and physical properties. right? For example, if I have to just quickly show you, these are alkanes, right? Single bonded carbon to carbon chain. But if I replace this hydrogen, I take it off and I replace it with a hydroxide group or hydroxyl ion, I have now changed the chemical property of that ethane to ethanol. It's an alcohol. So this is an atom or a group of atoms in this case that has changed the chemical properties and physical properties of that molecule. And that's what a functional group is, right? Try and use a diagram or a picture in order to assist your learning in a definition. Try and make it short, sweet science, so it becomes understandable to you instead of learning black and white writing from a textbook or a guideline document. Use colors and use pictures to try and get the answer out. 2.2 says, write down the structural formula. Now there's two parts to this question, although it's only 1 mark. And that is where our learners are losing out, because you're either making a mistake with the structural formula or the functional group. But you can't make a mistake with either one because it's only 1 mark. So you got to get everything right to get that one. So the structural formula means, in simple language, draw out a structure. And that is the simplest structure you can draw, a single carbon atom. But now they want the functional group of the aldehyde, which is a carbonyl group, C double bond O, and a hydrogen atom at either end of the molecule. That is your answer. If you put in hydrogens where I put the upside down V's, if you put hydrogens there, you have actually named that as methanol. And the examiner did not ask you for a name. He wants the general structural formula for any aldehyde. By you putting hydrogens there, you have named an aldehyde with a single carbon atom, which is methanol, which is marked wrong. The name of the functional group, the name, again, this is a dual-edged sword for 1 mark again. The name of the functional group of a carboxylic acid. So we got to write the name in English. Now many of us know that C double bond O, OH is the structural functional group. But the examiner asked for the name. So the name of C double bond O, OH is called the carboxyl group. Carboxyl group. And that is the answer. You cannot draw this. Do not draw this out at all, because that becomes option 1 when I'm ticking as a marker. And since this is your first option, I'll mark it wrong. The examiner wants a name. Make sure you give it in words, a name. They did not ask for a structure as in that previous question. 2.3, the IUPAC name of a compound is 2,4-dimethyl hexanone. So the parent name is hexanone, but it's 3-one. That is called the parent chain or the parent name, the main name of the compound. These are substituents, branches on that molecule. Hex means this molecule is going to have 6 carbons with an own family group, which is called a ketone. Ketone ends with O-N-E. So does this name of this compound. So definitely we are drawing a ketone. 2.3.1, name the homologous series. Well, that's the answer. It is a ketone. Right? The structural formula means we got to draw expanded notation. So this is 2,4-dimethyl hexanone. So the first thing I'm going to do is draw the main parent chain, hex 4, 5, 6, carbon 1, 2, carbon 3. That is the functional group of hexanone. Right? So we've drawn the main parent. We come back to the question. It says 2,4-dimethyl. So on carbon 2, there's a methyl side chain. On carbon 4, now you can draw it on the top or at the bottom, it doesn't really matter. There's a methyl side chain. And then you put in all the hydrogen atoms, making sure that you've got 4 bonds on a carbon. Now there's the tricky one here. 1, 2, 3, 4. Do not put a bond here, because now you go to 5 bonds on the carbon, which is incorrect. Carbon is in group 4 of the periodic table. So group 4 can only make 4 bonds. You cannot put 5 bonds or 3 bonds or even 1 bond on a carbon. But learners may argue there's a single bond there on the carbon. Correct, you are right. Because hydrogen is group 1 and group 1 can only make 1 bond. But there are 4 single bonds around this carbon. 1, 2, 3, 4. So I am following the rule of 4 bonds around the carbon. It is correct. Right? And you must put in the hydrogen atoms, learners. I know we teachers rush for time. We do not put in the hydrogen atoms when we are teaching because of time constraints. There's a lot to teach in organic chemistry, so we are rushing. 1, 2, 3. Can you see I'm 1 short there? And that is your answer for 2,4 dimethylhexanthreone. Right? The mark scheme is very precise. 1 for the functional group and the main chain. 1 mark for the rest. So it's only 1 mark. So if you missed out any of these side chains, you lost the mark. If you put it on the wrong numbered carbons, you also lost the mark. So this double bonded oxygen with 6 carbons and all its hydrogens are 1 mark. It's quite a lot. All the carbons, all the H's and the double bond O, then we give you this. So it's a lot of marks, less marks for a lot of work rather. Right, 2.4, we have diagrams that look like Spider-Man's web here. Right? Now this is a very contentious molecule because if I look at the name of this compound, it says 3 marks firstly. So it is not as straightforward as we think. It is a difficult question. Right? 1, 2, 3, 4, 5, 6. The straight chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, that's out, that's short. So our longest set of carbons is a straight chain of 6 or an L-shaped chain of 6 as well. 1, 2, 3, 4, 5, 6. Now if we look at the straight chain, you can look at the other chains as well, the L-shaped chains, they'll give you the same answer. We have a problem. On carbon 2 here, there's a bromide group. But on carbon 2, if you count from this side, 1, 2, you've got aryl groups, 2 methyl groups. And here, this is an ethyl group. Now, what is the rule for naming compounds? Does the bromo take the preference of the lowest number, or do the aryl groups take the number 2? That's why this is 3 marks. Does the bromo take the lowest number, or do the aryl groups take the lowest number? Have you read your CAPS document? The CAPS document says halogens do not take preference. It says it clearly. So the number 2 and the memo, the national memo also followed that document. This is carbon number 2. So we've got 1, 2, 3, 4, 5, 6. That's hex. What do we notice about all the bonds in that main parent chain? They're all single. So that is hexane. But on that main chain, you've got an ethyl branch, and you've got methyl there, and you've got methyl below it as well on the same numbered carbon. And we've got a bromo on carbon number 5 now. 1, 2, 3, 4, 5. So we've got a lot of things to name in alphabetical order. And this is where we lost our marks again. So bromo will come first. 5-bromo dash. Meth or eth first? Eth. This is carbon number 1, 2, 3, 4 ethyl, dash ethyl, dash. On carbon 2 there's a methyl. On carbon 2 there's another methyl. So it's 2, 2 dash dimethyl, and then you bring the word hexane down there. All one word. And that is the name of the compound for 3 marks. Quite a mouthful. Am I right, learners? Now expect this kind of chemical compound in your national finals. You are not always going to get naming for 2 marks like we had on the top here. You are going to get sometimes a 3 mark, and heaven forbid they put it for 4. Right? This was quite a mouthful. A lot of things to remember. There's a lot of branches. There's a dimethyl group. Many of you see when you write the word di, there must be 2 numbers here. If you write the word tri, there'll be 3 numbers there. Do you understand? Right? Ethyl groups are generally unseen in the exam papers. Yes, my friend? Then you say diethyl. But that's virtually impossible, because if you have many ethyl chains, remember ethyl is 2 carbons, you might change the length of the parent from 6 to 8 carbons. It might become a very long chain, 1, 2, 3, 4, 5, 6, 7, 8. Get the idea? Or going that way. So you might change the length of the parent chain. So be wary of that. It's very difficult or virtually impossible to have 2 ethyl groups. But you can have 2 methyl, as you see in this case. Okay? So be wary of a Spider-Man web question like this. That's what I call it. It could appear. The next question, name this compound. Now be guarded by the mark scheme. If 2 marks, it's 1 for the parent chain. 1, 2, 3, 4, 5. You can go that way. Or 1, 2, 3, 4, 5 straight. I'm going to go straight. Right? But always check the triple bond is your main function or homologue in this case. It must have the lowest possible number. 1, 2, 3. That's the third. That's the lowest. If I go backwards, 1, 2. So I have to number it backwards. That's the 2. Please write these numbers in pencil if you are doing it in the national final exam. Do not ink them. Okay? Because when you ink it, you are telling me there's 2 carbons there, when there's only 1 carbon. Do not draw or write in ink. So on carbon 2, I've got 1, 2, 3, 4, 5. So that's pent dash 2. On carbon 2 is the triple bond. An unsaturated hydrocarbon fuel. All hydrocarbons, this is a fuel. If there are no other atoms beside carbons and hydrogens, they're all fuels. That means they'll all undergo combustion with oxygen gas to produce CO2 and water. Any hydrocarbon with oxygen are fuels. They will burn to release greenhouse gases. Right? This is just by the way, I'm trying to kill 2 birds with 1 stone here. Right? So this is pen 2-ion, but on this carbon there's a branch. You can see you've left this out. There's the straight, there's the branch of the tree. This is the tree trunk. And that is CH3. And that is called a methyl. But that methyl is on carbon 1, 2, 3, 4. So it's 4-methyl pent 2-ion. Or is it pentan 2-ion? This is where the problem arises with spelling, learners. Is it pentan 2-ion? Audience? No, it can't, because pentan means there's single bonded carbons in the chain. There's no single bonded carbon there. So it's pent 2-wine, Y-N-E. Many learners in the examinations put E-N-E here. Why is E-N-E marked wrong? That describes alkene family. This is an alkyne family. So be wary of that, right? And this was 13 marks in total. I mean, you guys may get it for 18 marks at the end of the year. What's missing here, learners, you can quite clearly see there are no isomers in this question. So bank on that word isomers coming out in the exam. Which isomer, positional, structural, or functional? All three, please. Don't say this one won't come out. You are bluffing yourselves. Right, question 3 is in your books, right, audience? It's in your booklet. The boiling points of some organic molecules or compounds are shown. Y represents an unknown boiling point. So this is where the marks are going to be concentrated. Any unknown is going to be valuable marks. And the main thing for you guys is, how do I determine that unknown value? If the others are given and this one's not, it's a scientific guess. And you've got to guess correctly because it's going to be worth a lot of marks. You might have to compare Y to all of them. You might have to compare Y to 3 of them. I don't know. Right, let's get some marks. For the following compounds, write down the structural formula of F. Now, if you look at DEFG, butan is C4H2N plus 1, that's 9OH. And this is also C4H9OH, because that's also butanol. But its position of OH has changed. Can you see that? So they have the same molecular formula, different arrangement of the atoms. Yes, the OH group is on carbon 2. Here it's on carbon 1. Then you look at 2-methyl-propan-1-ol. Now if I have to draw that, 2-methyl, there's 2-methyl. Propan-1-ol, there's carbon 1. 1, 2, 3, 4, that's also C4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's also H9OH. So even molecule E and F are also C4H9OH. And if you look at G, it is 2-methyl-propan-2-ol. So what this examiner has done is move that for the last molecule, put it there. 2-methyl-propan-2-ol. So for the last molecule, he's moved that OH to the second carbon. But the formula, ladies and gentlemen, for E, D, E, F, and G is the same. And if you didn't know that by studying this table, you're going to lose all the marks therefore underneath. You had to recognize. So the moral of the story, ladies and gentlemen, is very simple. Go and draw out the skeletal structural formulas first of the named compounds the examiner has given. Because then you clearly see there is a pattern. And in this case, the pattern was D, E, F, and G have the same general formula. But they are all isomers of each other. They are either chain isomers or positional isomers. Do you understand? And we know from our teachers, a chain isomer, the straight chained isomer, has the strongest intermolecular network. The branched chained isomers have weaker intermolecular networks, right? So molecule D will have the highest boiling point of them all. And if you look at it, it is correct. It is 117. It is the straight chained isomer. When you go to butan-2-ol, you've taken that primary alcohol and made it secondary. That becomes like a branch, acts as a branch. So its boiling point will be lower. Correct. 95, 99. If you look at 2-methyl-propanol, it's funny business, we don't know. But the most branched is G. It's got the carbon as a branch, the methyl, as well as the propan, the all group on carbon 2, not on carbon 1. So this is the most branched, it will have the lowest boiling point, correct. So Y will fit where? 100 degrees Celsius, 81 degrees Celsius. Y will definitely be more than this, you all agree? Correct. So we know at least one part of Y is going to be more than the most branched, because that's the second most branched. Agreed? It's got the methyl that's common, but it's a primary carbon. That's a secondary. So this is least branch compared to that. But is this is more branch compared to D, isn't it? So this is more branch compared to D, but D is 117. So Y will be lower or higher than 117? Should be lower. So we know our range is between 117 to 82. Where does it fit? Let's see what they tell us. Let's start. Now I hope you guys do the same thing as me before you attempt a question. Because if you look at the mark scheme hasn't even come yet, because this is an absolutely long question. It's absolutely long. The mark scheme is, there's it at the top here, 17 marks. Now you cannot play with fire here, you're going to get burnt. 17 marks is more than 10%, people. So we can't be guessing. You must be absolutely certain with the examiner's table of information and how to interpret it. So what we've got in the table, we've got alcohols from meth to but in A, B, C, D. Meth, eth, prop, and but. The number of carbons in the chain is increasing, isn't it? That's all. And so will the boiling point. And there it is, correct. As the chain length increases, the boiling point increases because the molar mass increased and the strength of the London forces increased in these four. Now people will say, but sir, OL means hydrogen bonds. Hydrogen bonds are on the OH groups. The rest of the molecule has London forces increasing because the length of the carbons increased. Do you understand? Do you understand? If you don't, let me draw it for you quickly. If I draw methanol, I'm drawing the OH there with one carbon. That's methanol. If I draw ethanol, that's 2 carbons. Did I change this? No, there's the hydrogen bond there with ethanol or methanol with another one. This is called a hydrogen bond, people. I'm not changing that. I'm changing the chain length. And on hydrocarbons, when you look at H's, that bond there is the London force. So all molecules, when we teach organic chemistry, when we say there's hydrogen bonds in acids and alcohols, we actually lied to you. There are always 2 types of bonds in all molecules. We talk about the dominating one that determines the properties. The hydrogen bond determines the properties. But all of them got carbon-hydrogen atoms. They must have London forces as well. All molecules all have London forces. But the one that dominates tells you the boiling and melting points. Do you understand? So that's a nice way of writing it in the exams. When they ask you what kinds of bonds are in alcohols, you'll say weak London but strong dominating hydrogen bonds determine the boiling point. Then you are a top learner. That learner knows their stuff. You're now like a professor. Okay? When we teach, we only teach the dominating ones. But in reality, all organic molecules got London and them. The exception is these. These are hydrocarbons. The only type of network they have is London. The anes and ynes only have London forces. No other networks. All the other families got 2 other networks. But the dominating one determines the BPs, MPs and VPs. Boiling points, melting points and vapor pressure. Now let's come back to this. Now I can actually show you the answer because I've discussed the entire question completely now. Now you'll get full marks. The structural formula of F is very simple, right? is it propane? So I'll draw 3 carbon chain here. Right? Propane, F is propane 1 all. You can draw it on either the first end or the back end. It doesn't matter. Right? And it's 2 methyls on the carbon 2. You can draw a side chain either at the bottom or at the top. It doesn't matter. And please put your hydrogen atoms in. Letter that represents the positional isomer of E. Now E is butan 2-all. We are looking for a 2-all or a methyl. There's the 2-all here. Right? We want the positional isomer of 2-all. Now, if I got a 2-all there and 2-all there, have I changed the position? No. So I looked at the wrong molecule. Where has the 2-all changed position? Not only D, be careful. What about F? What all is that? 1-all. D is also 1-all. So the answers between D and F. Which one? D. Why not F? Why not F? Because F is a chain isomer. Examiner asks for? Be careful of English. F could have been correct. Because both of them are isomers, but one is a specialized isomer. Positional. So answer is D. Number 3, the letter that represents a chain isomer of E. A chain isomer of E. Now we can't look at D. We look at a shorter chain. We look at a shorter chain. But F and G are shorter chains. Which is the correct answer for number 313? Has to be G. Because if you take F, you've changed its position as well. It's 1-all. The examiner said chain isomer, not positional. So be very careful with the English. The answer is G. Many learners, because they look at 1 mark, it's easy. 1 mark questions are not easy in organic, as you can see now. Am I right? Yeah, good. I hope we're there online, all of us. 3.2, the boiling points of A and D increase. Let's go back to the question. Yes, we did it earlier. See our analysis. As chain length increased, the boiling points increased. Well done. Give a reason for the increase in terms of molecular structure. Chain length increased. Name the intermolecular force that causes this increase. Is it London or hydrogen bonds? London forces. Many learners, 99% of learners write hydrogen bonds. As I showed you earlier, the hydrogen bond didn't change. The length of the carbon chain did. Draw structures, people. Seeing is believing. Right. And now we come to the challenge question. Consider the 3 boiling points given below. 85 versus 108 degrees Celsius versus 122. From these 3 boiling points, choose the boiling point representing Y. Now, I think we already analyzed this. Y will lie between 117 and 82. Now, we've got 85, 108, and 122. Where will Y, which one is the best choice for Y? 85. You think 85, eh? The answer is 108. Now, I'll tell you why just now. The answer is 108. You see, if you look at 85, 85 is a 4 carbon chain, C4H10OH, 85. If you look at the original one here, the main one, this is the main one, option D here. The straight chain butan 1-all is 117, right? Y is also C4H10. But before 117 is a short carbon chain of propanol. Propanol is 97. Okay? A 3 carbon chain is 97. How can our 4-carbon chain be below this value or above this 85? A 4-carbon chain should be beyond 97. Agreed? Agreed? So beyond 97, 85 cannot be beyond 97. 85 is below it. So this answer here for Y must be greater than 97, because it must beat propanol. Must beat it. And your answer for Y is 108. When you're doing the comparison, when you are explaining it, now it's a very long explanation, you have to compare C to D with F. That is why it's so many marks. 4 marks. You compare C to D with F. For example, I'll do it now. C contains 3-carbon chain and a boiling point of 97, which has a weaker intermolecular network compared to D, which possesses 4 carbons in its chain. Is that clear? But F has a weaker molecular network compared to who? To D, because F is more branched. So if D is 117 degrees Celsius as a boiling point, F has to be slightly lower because it has 1 branch more than D. Do you understand? It's quite a challenge to explain this thing, because first time you are explaining 3 different molecules all at once to each other. So your English, unfortunately, I will show you the memo. I hope I do have it here. I'll show you the memo, and you're going to get a fright of your life on how we mark this thing. Can you see how much of English here? The examiner has first instructed the markers that the learner must compare molecule F with C and D. So if you compared any other molecules, you got 0. You got to talk about the 3-carbon chain first, propan-1-ol, then the 4-carbon chain, butan-1-ol, and those are easy marks to get. Chain length increased, molar mass increased, strength of the intermolecular force increased, higher boiling point, more energy for a phase change needed, therefore higher boiling point. The harder thing to do is compare it to F, which is branched. F is more branched, less molecular surface area, lower boiling point because of weaker intermolecular forces compared to D, not C, compared to D, because you're comparing isomer with isomer. Do you understand? C was not an isomer, it was a prop. D and F were C4H10OH. So if you look at it that way, it becomes easy to write it. Right? And you see, there's marks for that word. F is more branched than D. You don't have to write the names of the compounds. Look at the alphabets they used, F, C, and D. Right? If you don't like larger molar mass, say more branched, greater molecular surface area. Right? Compared to C. You must say compared to. You must say compared to. Then C. F compared to C. Have to do it. Have to. Yes? No, they don't have a larger molecular mass. Molecular surface area. You see, when you got a branch, if I show it to you with my hands, there's a straight chain. When you got a branch, that thing is sticking out. This long chain can't go close to it now because this thing is in the way. So there's less effective surface area to make the force stronger because the chain is now there, the second molecule. If the branch wasn't there, see how close they are. That's what they mean. Molecular surface area. Molar mass didn't change here because they're the same. They're the same. C4H10 H9, sorry, OH. The molar mass hasn't changed for the isomers. Only propanol changes the molar mass, is a smaller chain. The molar mass changed. If you go back here, this is not C4, prop is C3. So the molar mass here is less, 1 carbon short. Okay? The next question, Hydrogen bonding is responsible for relatively high boiling points in molecules A to G, correct? Draw two structural formulas of compound A and use a dotted line to show the hydrogen bonding. I think I've already done that, but I'll do it again. A was methanol. So you firstly, to get marks in 3.4, right? In 3.4, you draw two methanol molecules. The teacher said, draw two methanol molecules. Draw the two molecules first. Right. And now they ask you to indicate the hydrogen bond between them. Now the hydrogen of one molecule will attract the oxygen of the other with a dotted line. And there's the hydrogen bond. So 1 mark for drawing both molecules and 1 mark for indicating the hydrogen bond between the O of one and the H of the other. Or the H of molecule 2 with the O of molecule 1. We mark both ways correct. Okay? You all haven't drawn this before. Agreed? You haven't seen this before? Could appear again because this is an old question. Anything old can become new in 2024. Right? Because we have to see whether you guys understand hydrogen bonding. Okay? And that's the answer. Moving on to 3.5. A compound B reacts with propanoic acid in the presence of a catalyst. Now I'm chancing that compound B is an alcohol. Let me just double check. Compound B is ethanol. So let me write it down there. Compound B is ethanol reacting with oic acid. All with oic acid has to form an ester and water. Immediately you see oic acid with alls. That is your reaction, ester and water. So first answer, esterification. Type of reaction you make in ester. Esterification or condensation reaction. Now condensation is hard to remember. Don't worry about it. Learn esterification. Right? The structural formula of the organic product formed. Now this is rote learning. That means you must learn like in the old days, apartheid style learning, how we learned in apartheid. We cut and paste by hearting things. Unfortunately, organic is about by hearting, learners. You close your eyes and start recalling every page of the textbook. I hope we all can do that. We have to, because it's crunch time, it's November. This is our last shot. We have to close our eyes and by heart all the textbook information on organic. And we by heart this. All of these molecules, esters, end with something -yle, something NO8. And we take those prefixes from these words, eth and prop. Now, do I put the eth first and the prop second, or the prop first and the eth second? Oh, who cares? We can do what we want. And that is what grade 12s do. They do what they want. What is the rule, learners? Please help me. Which is first in this case, eth or prop? Why? Why? You learnt it like that. Well, I'm telling you how to learn it now. See, alcohol ends with the letter L. So does the word ethyl. So does this. Can you see it ends with L? So the alcohol ends with L. Oh, eth. That ends with L. Eth. Finish. So it's ethyl. Now, if you took the eth here, you can't go and write it here. Doesn't make sense. What's left over? Prop. See, many of you forget that NO8. You'll say proper weight. It's propanoate. Proper weight. That sounds weird. So please, wrong spelling is marked. Right. In your dreams. Wrong spelling is wrong. This is chemistry, people. This could be a medication that you're giving a child when you are a doctor and you can't spell. That's dangerous. You kill that child. Right. And we are I think, done with this. Naming compounds with isomers and boiling and melting points. Please, I've mentioned it yesterday. One of the three properties will come out: boiling point, melting point, or vapor pressure. Your trial exam at vapor pressure, maybe you get melting point end of the year. Please learn about the definition of melting point. And we come to our favorite friend, organic reactions. Right? We know how we love these web diagrams. We love them. There are 13 reactions we need to learn to master, and we pick out A, B, C, 9 of them are here, or 8 of them are here, or 9 of them out of 13. So we learned 13, 9 came out. So we need to know. We need to know what major means, what minor means, because the opposite of major is minor. That means you left out the minor product in these cases. Who knows, they might ask you to write the minor product at the end of the year. We'll never know. So we got to know Markovnikov's rule in addition reactions. I think we all know that rule, Markovnikov's rule. They don't use the word Markovnikov in the guideline document, right? I'll show you that rule shortly. Now, before you go through this entire thing, we got to figure out what's going on here. Let's start with letter A. From the double bond in, you got an ane. This has to be addition reaction. What did you add? You added hydrogen to make an ene into an ane. You have to learn that, people. You have to by heart that. Right? This question here, you got to by heart all 13 reactions, the general statements. Anes plus hydrogen gives you anes. It's called hydrogenation, learners. Now, reaction B, from an ane you became Y. I don't know what Y is, I don't know. Leave it out. Let's try. From the center, we add HCl. Oh, when you add HCl, you break that double bond to make a chloropropane. A chloropropane. But we don't know whether it's one chloro or two. We don't know yet. I didn't draw it. So from an ane to an ane, that's substitution. The name hasn't changed. Substitution. Reaction. You still got an ane in both cases. So you didn't change the name from an ane to an ane or from an ane to an ene. It cannot be addition and elimination. Right? Let's look at C. Oh, from a C means go backwards from an ane to an ene. That means you eliminating, isn't it? Elimination reaction. Let's get the names of our reactions right first, before we start writing balanced equations, which are a nightmare for some of us. Let's get these 1 marks, right? If you look at D, where is D? From a double bond, you're adding a hydrogen bromide. Oh, just like HCl. So you go back to an ane, a bromoane, a bromopropane. Why did I say prop? 1, 2, 3 carbons there in original. Again, we don't know whether it's 1 or 2, question mark. That's why the examiner is saying major product there. Okay? Is it 1 or is it 2 or both of them? We don't know. Then from the bromopropane, you get an alcohol. Now, how do we get an alcohol? Let's see. Oh, you're adding water to a double bond. That is called hydration. Adding water to a double bond is called hydration. And then you make an alcohol. So you're going to make an alcohol either with the OH there, or yeah, one of these is wrong. It's either 1 propanol or 2 propanol. We don't know which one. Who knows? This one or this one. That's why they're saying major. So Markovnikov's rule is pertinent in 1, 2, 3 cases here. And then from the alcohol, you're going back to an ane. That's substitution. Right? Substitution. So now we start. I think that is substitution. Yes, it is. From an alcohol, you can go back to a haloalkane. Absolutely correct. With zinc chloride catalyst. Right, so number 1. Name the reactions of A. A is addition. Some learners will write hydrogenation. That's correct. B, where is B? B is substitution. And E, from an alcohol go back. We elimination or dehydration of an alcohol. Elimination. So you studied the web diagram before you started your answer in question 4. This is how, ladies and gentlemen, I want you to do your question 4. Your question paper during invigilation, when the invigilator is walking past you, they must see all this. Then you start answering in your blank booklet. You don't just put question 4 and hit it, 4.1. You must be a genius if you're doing that. Even I got to do this. Okay? I can't just read that thing. We got to analyze. Number 2, name X. Now, where is X? X is a major product after adding a propene added to HBr. So let me do that separately. I'm not answering the question here. I'm doing rough work. Right? Just let me move this one side for a second, because we need to write now. Propene added to HBr. Okay? Right. Propene, C, added to HBr. And now, if we look at our molecule originally, there's carbon 1, carbon 2, carbon 3. Okay, maybe not draw that. Let me draw the hydrogens here. That will be better. Right? When it comes to addition reactions, you always break that double bond. So I'm going to break it. Right? I'm going to put in my original hydrogens, and you're going to see something funny. I put in my original H's. What is funny is carbon 1 and carbon 2 only got 3 bonds. 1, 2, 3. There's the new bond. Can you see it? Yes or no? And there's the new bond. So, correct. Between these two, I bust a double bond. And I made 2 single bonds. I saturated the compound. Now, I've got an option. The H can fit here or there. That is why we call it a major product. If the H goes in the first carbon, it becomes 2 bromopropane. If the H goes in the second carbon, it becomes 1 bromopropane. Now, what is the rule? Markovnikov's rule. Now, I teach it like this. I say the hydrogen will love more hydrogens. Which carbon here got more hydrogens? Carbon 1 or carbon 2? So hydrogen will love more hydrogens. And now I know the bromine will go there. So there's my major product. 2 bromopropane. Okay? That is it. Hydrogen from the HBr, I call it HX, where X could be Br, Cl, I, F, O, OH. So I summarized 6 reactions in one sentence. Did you all know that? You all go and learn HBr, then you say HCl, then you say HI, HF. I call it X, and X can be all 5. So I learned 5 reactions in one step. So why are you complaining that it's difficult to by heart? Any double bond with HX gives you Markovnikov's rule must be obeyed. Hydrogen loves hydrogen. Finish and clear. Right? And the good news is there is no second product. In addition reactions, you get 2 on the left, 1 on the right, and that's it. There's no other products. There's nothing here. And how will you know your answer is correct? From a double bond, you'll always get the reverse of that is elimination. It's not difficult, people. You need to think before you ink. Right? So now I'm going to answer the question. Remember, many of you do this as the answer. The examiner did not ask that. Where's my question paper now? The examiner did not ask that. The examiner asked this. Write down the name of X. What you've done here is called a balanced equation. Agreed? Agreed? There's the name here. 2-bromopropane. Right? 2-bromopropane. Yes, it took a lot of thinking to get that 1 mark or 2 marks. For reaction D, the type of elimination reaction. Reaction D. Where is D? D. Right. From a halogen haloalkane back to an ane. It's dehydrohalogenation. Dehydrohalogenation. It is theory, people. You got to learn it from the CAPS document. When you removed an H and a Br from this, when you take the H and Br out, you go backwards. It's called dehydro, take out hydrogen, and take out the halogen. Right? So it's dehydrohalogenation. 2 reaction conditions: strong base, concentrated, not dilute, strong base, example KOH, or LiOH, or NaOH. Now that is one condition. Many of you think that's 2 conditions. That's one answer. The second answer is high temperature. High temperature, or heat strongly. Heat strongly. If these conditions were opposite, dilute versus low temperature, it becomes a substitution reaction. Make a note of it. If these conditions were opposite, dilute base with low temperature, mild heat, it is now a substitution reaction called hydrolysis. If the reactions were the conditions were the opposite, dilute base with low temperature, mild heat, it becomes a substitution reaction called hydrolysis. Please remember that. 4.4, right? Right, I will show you the memo now, because why am I rushing? We need to finish a lot of work, ladies and gentlemen. I'll show you the memo for 4.4. Write down the formula of the inorganic reactant for F. I'll just look at F quickly. F goes from a bromopropane directly to an alcohol. So, bromo to an alcohol, there it is. Can you see it? Haloalkane plus something OH will give you an alcohol. Okay? Is that clear? What OH? It will be a base again, dilute base. Formula of the inorganic product, as well as, next question, the balanced equation for G. Now, where is G? G is an alcohol. There's the alcohol here. Oh, by the way, the alcohol is not that. It is this one. The major product is this. I showed you what Markovnikov is now. Hydrogen loves hydrogen. If you add water, HOH, the hydrogen will go to carbon 1, the OH will go to carbon 2. There's the hydrogen there. Right? Hydrogen loves hydrogen. From here, going back to ane. From an alcohol going back to ane. Alcohol going back to ane is called a substitution reaction. Right? The memo for that. This is 4.4. All right. Lovely stuff. 4.4. Right. There's your memo. 4.4.1. I find it strange they left out lithium hydroxide here as well. Huh? Lithium hydroxide is also a strong base because group 1 metal. Lithium, sodium, potassium. Yeah, lithium is not as strong. It won't be as effective, but it'll still work. Okay. 4.4.2. Alcohol plus halogen acid will give you chloroalkane plus water. This is the third substitution reaction in your textbook. Many of us forget to learn. The alcohols can go back to the haloalkane. Haloalkane plus that goes back to alcohol. This is nice, the way this thing is set up. That plus that will go back to this. But this plus this will go back to that. So technically you're learning only two substitution reactions in the textbook. Because one is like a reverse of the other one. Right? And this should have been is this a secondary alcohol? Oh yes, talking about secondary. Many of you don't understand what these words are, primary, secondary. When we talk about secondary, it doesn't mean second carbon. Take that nonsense out of your head. The carbon with the functional group, in this case is OH, is surrounded by two other carbons. That's called secondary alcohol. The carbon with the functional group, hydroxide. Is it important to say hydroxide functional group? Yes. This could be a chlorine. Then you say the carbon with the halogen functional group if it's chlorine. You got to say that because the memo doesn't leave the word halogen out. So in this case, if I asked you why is it a secondary alcohol, the carbon with the hydroxide group is surrounded by two adjacent carbons. If this was a carbon on the top, then that will be a tertiary alcohol. The carbon with the hydroxide functional group is surrounded by three other carbons. Okay, do you understand? Good. It must appear because learners are not getting full marks for the definition of secondary and tertiary. So it will be set. Thank you. And that is our conclusion of organic, ladies and gentlemen. It is worth 58 marks out of 150 in the examination, which is more than 33%. Please do not play with fire, guessing answers on organic, because if you get full marks for organic, you have passed the exam paper. You have got more than 30%. You see this question 5 to 10, you can turn over and say, I'm done, I've passed. I've got 50 marks for organic, I've passed, I got all right. And I've got 20 more in multiple choice. So 50 plus 20, you've got 70 marks before you even attempted question 5, 6, 7, 8, 9, and 10. So how are we failing paper 2 candidates is a mystery. You guys need to break down your learning strategies to maximize your credit in the paper. Have you all thought of doing that before? Have you thought about getting good marks in organic so you maximize your credits and get good marks overall? No. Why not? We need to by heart our organic, ladies and gentlemen. Now let's move on to question 5. Reaction rates. Now this is a very common question in the exam. They always give you an acid with a base or an acid with a metal to produce salt and hydrogen gas. Now why do they do this? Because of one reason. If you want to measure rate, you measure the rate at which a solid decomposes or the rate at which a gas is formed. And if you look at both these equations, the metal is the solid and here the solid here is the carbonate. So when you ever want to measure a rate to determine how fast something is used up, always measure the rate at which the solid is getting finished. How many grams per second, per minute, per hour is being used up? And if it's very, very slow, your reaction is slow. The rate is low, reaction speed has decreased. Right? If the rate is high, the rate at which bubbles of hydrogen gas form, bubble, 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 very fast. High reaction rate. Because we can collect that gas and a certain time to measure how fast we collected it. So that is the reason why the examiners always set a graph that starts low and finishes up. That will be for the gas, always. Or they draw a graph like this. The reactant being used up, 8 grams of solid getting finished. That means at that time, final time, there's 0 grams. So it's the limiting reagent. You will always get one of these two graphs in the exam. If you are increasing with amount per unit time, it will always be the product time graph. So products are on this side, and the product you're looking for is always a gas. If it is a reactant time graph, it will be the solid being decomposed, or sometimes a liquid being used up. Very rarely they've done that. Last year's exam had it, right? A solid being decomposed until it's finished. If it's not finished, they'll do this. Dot, dot, dot. I started with 8 grams and I flattened the graph at 5 grams. How many grams were finished? I started at 8, I flattened at 5. 3. Many learners write. How many grams were finished? They write 5. 5 is what's left over. See, the time is going by. You still got 5 in the test tube. That's called the excess grams. So the other substance will be the limiting reagent. Am I clear, people? These things are always repeated. They just change the balanced equation. And please check that the equation is balanced, please. It must be balanced before you attempt stoichiometry. Now, we are clear. This examiner or these learners have measured the carbon dioxide gas collection. There it is. So this is a product versus time graph. But what they've drawn is not the mass collected. The mass is missing. What they measured here? What's this G dot minute? What is that called? What is that called? They measured the rate of collection of gas. They did not measure the mass gained from 0 grams. So you know they're going to ask you, calculate the mass gained. I think you know that. Agreed? Agreed? So this is a new kind of a question. They measured the rate at 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, 40 and 50. And as the temperature increased, what happened to the rate? Is this direct proportion? No, it's not. Show me a straight line in this graph. You use the word direct proportion, you get not. You will write in English, as the temperature increased of the reaction contents, so did the reaction rate. Finish. You use the word direct proportion, you get not. This is not a graph starting from the origin. A straight line from the origin, like this pen, that is direct proportion. This graph does not look like that. Do not use mathematical terms ad hoc as you please. Because some of your physics teachers are maths teachers too. They're good in maths. They'll fail you. They'll fail you. All right, firstly, definition. Define the word rate. I'm tired of this question. I'm tired of this question. I hope you are too. But if you're getting it wrong, you mustn't be tired. You cannot use the word rate in your answer. Rate is equal to delta C all over delta T. Change that to English now. The rate is the change in concentration per unit time of the reactants or products. Convert this to words and you get 2 out of 2. Another thing you can replace is this word, is amount. Rate is the change in amount of the reactants or products per unit time, or volume, or concentration, or mass, or even mole. You got 5 options, pick one. That's what rate is. The change in the top value over per unit time. Divide by time means per unit time, per unit change in time, right? Delta means change. You must have the word change. Change in concentration or reactants per unit time. State two conditions that are kept constant during this experiment. So this child has varied temperature. So what factor hasn't changed in this experiment? Let's see if they gave it to us in the English. No, they didn't. Which factor has these learners not changed in the factors influencing rate? They kept it constant. Remember, how many factors have changed here? One. This one. Temperature has changed, influencing rate. Many of you say two axes, two changes. One condition changes in a practical, people. In life science, physics, any prac. You change only one factor. The other 5 or 6 factors are constant. If you've got many factors changing, your experiment becomes absurd, absolute rubbish. Your results are not fair and reliable. So you change one factor to ensure a fair and reliable test. Can you think they'll ask you that question? How many factors were changed or varied? It's one. The factors that didn't change are here in the equation. The concentration of the acid and the solid. It's not crushed powder. It's still a solid. So surface area, isn't it? Agreed? Agreed? So the answers were in the phases of matter. Many of us don't read these things. They think it's just there for fun. This is telling you this got a concentration, AQ. It's a solution. So concentration of HCl and state of division or surface area. Surface area of who? The solid. Concentration of HCl. Please don't write C, write concentration. Many of you write concentration, full stop. Tell the examiner it's the concentration of the acid. Because there are 5 chemicals here. Which concentration are you talking about? I don't know. I'll mark it wrong. I'll fail you. My learners, if they didn't put the HCl, I'll give them 0. I'll tell them you must write proper science. Don't know, no half-truths. You got to be precise. Remember your goal, all of you sitting here, you're sitting here for 300 out of 300. You're not sitting here to get 30%. I must make that very clear to all of us online as well. Nobody goes for extra lessons on a public holiday to get 30%. I certainly didn't come here on a public holiday for you to get 30%. You're coming here to get 300. In other words, you are becoming Mr. N. Aribans. You're becoming me. That is why you are here. Because in 10 years' time, I expect you to be sitting in this chair. I'll be dead by then. Right? So, don't think it can't be done. It can be done. It's your attitude that develops your altitude in life, people. Remember that. Right. Use the collision theory to explain the graph. So we're going to explain temperature. Right. Anything with long words, I want to rush a bit because memo time. Right. You need to look at the memo because you must see the underlined words. That is where the marks are. Those underlined words, when you talk about temperature, you must say the particles, each particle gains more energy. You must state that. Then you must state, if they have more energy, the speed of each particle will increase. Therefore, number of collisions per unit time will increase. Therefore, number of effective collisions per unit time will increase. And therefore, the rate will increase with an increase in temperature. It is not negotiable. Right? If you Afrikaans, the Afrikaans version is there as well online. Right? So, please take this down for the collision theory versus temperature. This was the answer that we expected in your trial exam, KZN. Temperature influenced that reaction. which most of us didn't know, because metals corrode exothermically with an acid. You all didn't know that. If you did, well done. Have you all taken it down? No. Take it down. Your heading will be collision theory. Collision theory for the factor temperature. Okay? The underlined words, you see there's a slash here. Where's that slash? See, you don't have to write both words. Sufficient kinetic energy to overcome activation energy. You don't have to write the word or as well. If you wrote this, you don't have to write that. Okay? These answers are all in the just-in-time booklets on the school websites or the DBE websites. All these answers are taken from there. They're not that special. They're taken from the just-in-time websites, the DBE websites. Right. Now we come to our 8-mark level 3, which is compulsory. The learners obtained the graph using 5 grams of carbonate but with excess HCl. If you see the word excess, you can't use number of moles. You cannot use the number of moles of the excess because you don't know how much is excess. So don't even waste your time looking at any information on the excess acid. The moment you do that, you are going to lose these 8 marks. It's not 2. 6 plus 2, 8. The examiner made it generous, broke it up into 2 parts. You're going to get 8 or not here, nothing. You're either going to get 8 or 0. Now, what's dangerous about this question? The examiner gives you grams of carbonate, but he gave you the rate of who? Rate of who? Carbon dioxide. You have no information to link carbon dioxide's mass with the rate of it. You can't link the mass of the carbonate with the rate of CO2. They're 2 different chemicals. You need to link rate of CO2 with mass of CO2. Then you can work out exactly how much time has elapsed, because that's what the examiner wants. Calculate the time taken for the reaction to run to completion. So when all this is finished, the reaction will stop. But when all this is finished, you'll get the maximum amount of mass collected of carbon dioxide as well. If you draw the carbon dioxide graph, right, this came out in your trial, the mass of carbon dioxide, you see that mass is missing. We don't know it. And we also don't know at what time this graph flattened, the final time. This is what they want. This is what the examiner expected you to imagine. When you looked at this, you needed to draw your own for this and put a question mark here. If you didn't do that, you lost 8 marks. We need to find the mass of the carbon dioxide, although we are given the mass of magnesium carbonate. But I think we did it in grade 10. Grade 10. Firstly, in stoichiometry, select the 2 relevant chemicals. 10:30, yeah. Select the 2 relevant chemicals from your stoichiometric relationship. And you can clearly see the ratio is 1:1. So now I'm going to transpose to my paper. Select the 2 relevant chemicals. Magnesium carbonate is to carbon dioxide. Remember, our goal is to find mass of carbon dioxide. So we need molar mass, which is 44 grams per mole. Number of moles carbon dioxide is missing. The ratio is 1:1. That's a big help to us. Right? So we've got 2 question marks here. And we've got the rate. The rate, let's go back to our question. The rate at 40 degrees Celsius. We take our dotted line with a ruler. Do not do what I am doing. Use a ruler. Because the examiner asked the question, at 40, calculate the time. So we need to get the rate at 40. Make sense? Make sense? Right, and you go here, it is half. So the rate is half a gram per minute. That's not going to help me. It's not going to help me a single bit, because as I did before, rate is equal to this grams. So it will be not the change in concentration, but the change in mass per minute. But we don't know this, we don't know this. We only know the rate is 0,5. So we got a lot of question marks. We got a lot of question marks for carbon dioxide. A lot. But we do know the complete mass used up is 5 grams here. We also know the molar mass is 24 plus 12 plus 3 times 16, 48, 58, 60, 84. 84 grams per mole is that one. And we know baby M is 5. So immediately I can get some marks. Always look for number of moles to solve it. The moment you start with baby letter N, you're getting marks if you put values. This child will get no marks. They put no values. Now they're getting marks. 5 divided by 84, which is 0,0. It's some weird number. 0,0595. I'll round it up to 0,06 moles. But what is my ratio of carbonate to carbon dioxide? So what can I do to the moles on this side? Transfer it to the carbon dioxide. Agreed? Because identical ratios will have identical moles. Identical moles have identical ratios. It's a law of stoichiometry. I think you're all aware of that. So 0,06. I think I'm smiling now. I got big M, I got N. Can I find baby M? So baby M is equal to N times big M, which is equal to 006 multiplied by 44, which is how many grams, people? It will be a very small answer. .64 grams. But that is not our answer. The examiner wants this time. How do I get this time, ladies and gentlemen? How can this answer help me get the time? Isn't this, remember my graph, ladies and gentlemen? Carbon dioxide flattens at that time. This is what I want. It flattened at 2,64 grams now. Agreed? So what was the starting mass? What's 2.64 minus 0? Isn't that to be called delta M? So rate, there's the equation. 0,5 is equal to 2,64 minus 0, all over T final minus 0. Isn't the time also starts at 0, 0? Final time is T, initial time is 0. Yes? Right, and you'll solve for the final time. Right? 0,5 T final is equal to 2.64. So T final is equal to 2.64 divided by half. How much? 5,28 minutes. Because the rate was given in gram per minute. And this will be worth 8 marks now, ladies and gentlemen. Right? So you had to calculate the mass produced of carbon dioxide first. And once you produced it, even if you left out these zeros, I'll mark it right. In fact, my answer is better than a memo because a memo don't even have the zeros. Right? I'll show you the memo. Hey, I don't like showing this memo because other answers underneath. Hey. Right, hide it. Hide it from the learners. Right, that is your memo. Okay? They left out the zeros. I subtracted with the zeros. Okay, there are many options. You look at this option here on the left. Follow my pen. There. Please look at the marks, the ticks. This tick is for the 44. So if you worked out the molar mass of carbon dioxide, you got a mark. Even if all this here was all nonsense, you got a tick for this. Right? Look at that. Formula mark. Provided you got substitution. Right? At the end, substituting the rate in the correct place. This was given. If you wrote your own equation and put the rate, so you can get 1, 2, 3 out of 6 with no thinking. Isn't that amazing? 50%, a D symbol in physical science, and you wrote everything that's wrong beside the given information. Given. And everything else you got all wrong. You got 3 out of 6, ladies and gentlemen. So when you look at these difficult of kind of a question like this, when you look at these nasty things, hey, what is this rate versus temperature? I never saw this prac before. Don't get scared. When you look at the memo, you could have got 3 out of 6 for things that you know from grade 10. Molar mass you know. Formula, baby M over big M you know. The rate you know is change in amount over change in time. You know where to substitute the answer for rate. You got 3 out of 6. So don't leave this 6-mark question blank. Suddenly you lost all 6, you left it blank. You could have got 3, you then attempt the question. Now 6 or 5.4.2, right? Let me just change this page here, people. 5.4.2. 5.4.2 asks to calculate molar gas volume. What's the symbol for that underlined term? Thank you. It's VM. Many learners going to write V there. Now, why is VM asked in this question? This is not STP. STP is 0 degrees Celsius, standard temperature. So you should have realized that this is not 0. Hence, this is VM. See, I warned you about this. VM is never going to be 22.4 again. There is V given if 1.5 liters of carbon dioxide were collected. So now we're going to show all working. N is equal to V all over Vm. V is 1.5 dm cubed. Lovely, I like that. Given in SI unit. Problem is N is missing. Vm is Vm. What is the number of moles of carbon dioxide? And if you go back to your memo, here it is. Now let's suppose you had it wrong. You take your wrong number of moles and you put it here and you'll get full marks. 006. And now you get Vm to be 1.5 divided by 006. I think it is, okay, let's show you the answer now. It is 25 dm cube per mole. Now, the unit is where you'll get caught. Copy it from the back of the data sheet. It's there. You don't know the unit? Go copy it from the back of the data sheet. Because many of us don't write the unit for Vm. When we teach to, we don't write it. Agreed? I don't write it. I'm not ashamed to admit it. I don't. It's in the data sheet. Must go and read it. So I'm going to copy it too because I forgot the memo. Oh, dm cube dot mole negative 1. 25 dm cube dot mole negative 1. Go and copy that thing from the data sheet. The unit is standardized across the board. Okay? Now it was only a measly 2 marks, ladies and gentlemen. 2 ticks. See what the ticks are. Formula and answer with unit. So again, you could have got 2 out of 2 with wrong answers here, provided your substitution is right and your unit is right. That means you got 5 out of 8, a C in physics. Not a F, a C. So do not underestimate the mark gained by you with these difficult questions. You can gain the marks. Don't give up hope. Put pen to page and write. And you're going to get marks. You will pass. Am I clear, all of you? Can you see how easy it is to get marks you just gave up? Did you realize you're giving up for nothing? I hope you did. Those of you online as well, don't ever give up. Put a pen to page and solve the question by thinking with comprehension. That's the key. Think with comprehension and analysis. All right, we will go off shortly for a half an hour break at 10:30, right? And we will come back and resume at 11 to finish this paper at 12 p.m. Right? And then we will start with paper 1 thereafter. Thank you, audience.
There we go. That was Mr. Haribans, the facilitator for the physics workshop, where he is focusing on chemistry. And yes, this is the Awqaf SA and Falaah grade 12 physics online workshop. I can definitely feel it. Can feel it in my bones that some of the learners that's part of this cohort are definitely going to go on to be doctors, scientists, pharmacists, and the likes, because Mr. Adibans comes with 20 years of experience in physics, and we know that this session, hopefully, this will be a contributing factor to your success in the up and coming final grade 12 examination. So we have emailed all participants the workbooks that Mr. Adibans is working with and is basing the session on. We have emailed you 2 files, so just have a look at that. We have also posted these workbooks, the PDFs of them. You can download it from the Awqaf website. It's going to assist you as part of your revision for the final examination. Khalid is in the building and he will be joining us. He'll be the continuity presenter for the course of the session. Kindly be advised that the sessions are hosted on Awqaf's YouTube platform. Please do subscribe to our YouTube platform. We've got some workshops that's up and coming that'll be of benefit to you. Please share this with your fellow learners in your class, and please keep that comments going. Some of the comments have been very encouraging. Some of the learners have been deriving some benefit from these sessions. This is the first time that we are hosting this online physics workshop. This is part of Alphalah's CSI project. It's a outreach project. Because it is the school holiday, Falaah has been hosting a maths workshop. We did maths paper 1 and 2, grade 12, at Falaah over the weekend. And Monday we did physics. And today we are focusing on chemistry. All of these videos, you can access this on Awqaf's YouTube platform, Awqaf South Africa. Please do subscribe. We've got quite a few maths workshop papers to assist you with your revision. So yes, we'll resume again at 11 o'clock.
T minus 15. T minus 15.
It's over to you, Mr. Ariman. Take the seat you want.
Thank you, sir. Welcome back, ladies and gentlemen. We are now in session 2 of the entire tuition program. All right, we have just finished question 5.4, the last time I spoke to you during the first break. And now we're looking at the termination of the question in 5.5. Okay? We're now coming to the question on the Maxwell distribution curve that looks very similar to the diagram for the endo and exothermic reaction graphs, but is a completely entire different concept. Now, the Maxwell distribution curves, they are drawn to help us extract the factors that influence rates of the reactions in terms of using the collision theory to explain our answer. Now, what you've seen in front of you, before we go on to the answer and the question, we have got to bear in mind our 3 factors that influence rates. The big 3 are the change in concentration, right? Followed by a change in temperature, followed by the use of a positive catalyst. Because we, for our CAPS purposes, we need to know how to draw this graph when concentration increases or decreases, when temperature increases or decreases, or when we use a catalyst to lower the activation energy. How do we represent that new curve on the original curve? Now, many learners, when they are drawing these curved graphs, they are forgetting to label their graphs. Now, one of the instructions in the exam memo is if the learner has not labeled the graph A and B, or X and Y, and P and Q, award 0 marks. So if you don't label the graph, like you see clearly, the original graph in this question is called A. If they ask you to redraw the graph, you must clearly label it as A. It is mentioning that in the question. Now, many of us forget that label A. And when you answer the question correctly with your new graph, you also forget to label that as B. So the examiner or the marker does not know what is the answer and what is the question, hence you are awarded 0 marks. So please, learners, when you look for questions of this type, where you are drawing graphs, or rather sketching graphs, clearly label, must be underlined by you. You go and label it according to the examiner's instructions. Because if you don't, I'm afraid you are going to be awarded 0. That's the unfortunate thing. Okay? Now let's look at our question. The Maxwell distribution curve represents carbon dioxide production at 40 degrees Celsius. In the previous question, that's 0.06 moles of carbon dioxide that we produced. Right? They want you to redraw this graph in your answer book and label it A. So when you redraw it, it means the axes must be labeled as shown. There is no mark for labeling the axis, unlike what I've ticked here. You will write exactly what's here, and then draw your curve to look like something in the question paper, which I will do shortly with you as well. Next, you got to answer the question. On the same set of axes, draw the graph or sketch the graph that will be obtained at a temperature of 20 degrees Celsius. Now the question was set at 40 degrees. Now they ask you the temperature has decreased. Now if the temperature has decreased, will the shape of the curve change? The answer is no. How does the curve change is asked for 2 marks. Now, when you were taught this, or when I teach it to my learners, I always ask them to draw a dotted line to represent the activation energy on the graph. Now, the shaded area, if I've got another color pen, I can show it to you. The shaded area after the activation energy is the number of effective collisions. Number of effective collisions per unit time, right? The unshaded area where there's question marks is the number of collisions that are ineffective. So when in any reaction, there are these types of collisions in all reactions. The ineffective collisions, they are ineffective because they haven't overcome the activation energy. Their energies are here. 10, 20, 30, 40, 50, 60, maybe 90 kilojoules. But this could be 100 kilojoules per mole, for example. These are less than 100. So they haven't broken old bonds yet to make new bonds. So hence these collisions are ineffective. The area under the graph, the area under the curve is effective collisions. Now, common sense, the bigger the area, the bigger the rate, because all the effective collisions are here. So if you've decreased the temperature, your area in your new graph has to be smaller than the old. Your area has to be smaller than the old. So you can draw your graph with an area smaller than the old, right? See, that area now is this section, see? It's smaller than the previous. Can you all see that now clearly? But the peak of the graph must be higher than the old, right? And that is your new graph B. Ironically, at 20 degrees Celsius, the peak is higher, but the area is smaller. Can you see that big difference? In the original graph, at a higher temperature, the peak is lower, but the area is larger. Is that understood? So you redraw that graph A, and on that same set of axes, label your new graph B at a lower temperature. Obviously, I forgot the degrees Celsius there, right? And you should get 2 out of 2 for that. Bearing in mind, do not leave out these labels. The number of molecules versus kinetic energy is important. If your labels are missing, your graph does not make sense. You don't know what you're describing. It'll look like a hat. I might think it's a hat, right? And that is the end of rates. If you look at the total marks, 18 to 20 marks out of 150 is a big chunk of change in the final examination, right? Now we come to question, or before we go there, question 6. Question 6 should be on equilibrium, where the rate of the forward reaction is equal to the rate of reverse reaction in a closed system. That is the definition of chemical equilibrium. The rate of the forward reaction is equal to the rate of the reverse. Many learners forget the word rate. There's no such thing as a forward reaction equals the reverse. A reaction cannot equal to each other. The rates can be equal. Okay? Or in other words, the number of effective collisions per unit time can be equal for both forward and reverse reaction. Closed system is important. Do not use the word isolated in paper 2. You use it in paper 1. Right? Define the word chemical equilibrium. I've just done that for you. Excuse me. Yes, sir. The zooming. Okay. What other definition could they ask in response to this? What is the meaning of the word reverse reaction? Explain the word dynamic. Right? State Le Chatelier's principle. Right? These are common questions that appear as theory. So, Le Chatelier's principle was examined in your recent trial exam. A reverse reaction means the products can become reactants and the reactants can become products in that system. Dynamic means the forward reaction and reverse reaction occur simultaneously. Okay? All right. 6.2, graph question. Again, when learners look at a graph, they get scared. Now, there's nothing to be afraid of in a graph question. Nothing at all. Right? The graph below shows the concentrations of the reactant and products that vary with time. Yes, the concentration initially is a maximum for only reactants. It's a maximum. You would read that value in moles per dm cubed. That is the value you put in your rice table. Initial concentration. There, you take it from there. Right? The initial concentration of your product, there's it there. That's why you write 0. Your products always start from 0. So this is a reactant time graph and a product time graph in one question. Okay? And as it passed 4 seconds, the concentration started becoming almost constant at exactly 6 seconds, or 6 minutes, sorry. The same thing with the products. As the concentration increased from 0, towards the end, it started to flatten there at that point, at 6 minutes. So this graph will end up being flat. That means the concentrations are constant. And that is the definition of equilibrium. When the rate of the forward and reverse reactions are equal and all concentrations of products and reactants are constant, not remain the same. I don't think this value on the y-axis is the same as this. They're not the same. Don't say remain the same. That value is higher in concentration than that. Excuse me. Right? What we notice here is this flat part of the graph is unlike the previous chapter. When the graph was flat in rates, it means the limiting reagent was consumed. Here, it means the concentrations of all reactants and products are constant. Therefore, equilibrium is established and the rates are equal. That's what must go through your mind before you attempt 6.1. There's a lot of thinking in chemistry, paper 2. Which of the curves represent the change in concentration of the products? Now, obviously, I just mentioned that the first curve is reactants. So the products is this one. So it is graph X. First answer is X. Give a reason for the answer. There's the reason. I've underlined it. The concentration starts from 0. At the start of a reaction, you have no products. Hence, the concentration is 0. Your answer was in the coordinate of the origin. At 0 seconds, there is 0 products. right? And you write that as an answer, you get full marks. Correct. Right? 6.22. How does the rate of the forward reaction compare to that of the reverse at t equals 4 minutes? So at this time, they want the rate. Now the rate is actually the gradient of the graph. Right? Now this graph is never drawn to scale. Many of you will think that the tangents, the gradients here are equal. Those tangents, the gradients are not equal. Because at the start of the reaction, your container was empty. You had no products at 0 seconds. So you can't talk about reaction rate of products. As you start building, if this is your test tube of molecules A and B reacting to produce C, at the start there's no C. Right? You've got millions of A, millions of A, millions of B, but no C. When they collide effectively, one C molecule will come out. But who's outnumbering who? Are the reactants outnumbering the product, or the products outnumber the reactants in moles? The reactants. So where will the collisions be more effective initially? In the reactants or in the products? So that's your answer for 622. At 4 minutes, this is still early in the reaction chamber. So how does the forward reaction compare to the rate of the reverse at 4? The forward reaction is higher. You've got more particles colliding here. It's higher. It's only 1 mark. You got less product particles, only 2 of C there. But you got 2 million of A and B colliding. So the reaction rate will be higher initially here. At 6 minutes, the rates are equal. But the rates are always changing before that. I hope you understood that. Right, next. Now we come for I call this the stinker question. There's the danger. The Kc value is 004 for this reaction at temperature T. Calculate the moles of iodine present at 6 minutes. So you need to calculate the moles of iodine present at 6 minutes, means at equilibrium. Now, where is the question? Because the question is on the previous page. Question 6. Pure hydrogen iodide gas, Hi, of concentration 1 molarity is sealed in a 500 cm cubed vessel. 500 cm cubed is dangerous for physics or chemistry. You immediately put times 10 to the minus 3 and change it to dm cubed. The moment you see any volume in cm cubed, I want all of you online and in the audience to do this. Because if you leave any volume in cubic centimeters in paper 2, you're going to fail. It's not a question of even getting 30%. You're going to fail. You're going to get nothing right in every question with stoichiometry. Nothing. So please, I urge you to divide by 1,000 or do times 10 to the minus 3. And if you want to, you can enter it in a calculator. 500 exponent negative 3 is actually 0,5. It will tell you it's 0,5 liters. dm cube means liter. So we've got the volume of the container. We've got the concentration of Hi. The reaction reaches equilibrium according to the... So we've only got one value. The initial concentration of the reactant Hi. We've got no other information on concentrations on I and H. Now, that's why it's 9 marks. We have to determine our table. Now, let me write this down, please. Right. Right. Let's see how we go. This is number 6.4. 6.3. Right. 6.3. We've got 2 Hi, arrow, arrow, H2 plus I2. Balance the equation. I think it's already balanced. 2:1:1. Let's confirm they are all gases from the original examiner. Yes, there are gases, so there will be a Kc expression of all three. This is definitely a homogeneous system because the phases of matter are identical in the reactant and product. They ask you what is a homogeneous system? The phases of matter of the reactant and products are in the same phase. Is this decomposition or synthesis? It is decomposition. The hydrogen iodide has decomposed into its gaseous hydrogen and gaseous elemental iodine. Could ask you grade 9 question if it's decomposition. So that's our ratio taken care of. Now the examiner said initially, I-N-I-T-I-A-L, initially 1 mole per liter of HI was given or entered the system. Initially, concentration of HI was 1 molarity. What I'm going to do is, you see, ladies and gentlemen, I can convert that into number of moles, C times V, which is 1 times half. Because half was the volume, which is 0,5 moles. Now, when your teacher taught you to design the rice table, I always teach 2 ways. Either choose the rice table in concentration or convert the concentration and choose to do it in moles. Now, this examiner never gave that answer. They gave a concentration. So he is telling me, design the table in concentration. So I will not have that last row in my table divide by volume because I already got the thing as mole per liter. I got it as a concentration already. Because Kc, if you didn't know, ladies and gentlemen, Kc means the constant value with concentrations. That's why you divide by volume in the end. So if this unit was given, you will add that 4th row in your table. What is the table? My table is going to have 3 columns, right? Versus 3 rows. Initial concentration, change in concentration, equilibrium concentration, because I am not putting my values in moles. I'm taking a hint from the examiner. Leave your table in moles per liter. So initially it was 1 molarity. This is a reactant. At the start, do I have any hydrogen and iodine? 0. The change in concentration was not given. Let's go back to the question. The examiner gave us no information. But what they did tell us in our question is the Kc value is 004. So let me get 1 out of 9 first. Okay? I'll write my Kc expression. It's the product's concentration over the reactant concentrations. Right? Let me pull my page slightly there. Right? The products were HI or H2 and iodine. Let's go back. The products are always on the right hand side and the ratio is 1 and 1. So putting these ones are obsolete, but you can put it. The reactant concentration is HI. So I'll go back, HI, but now the ratio is a number 2. So we don't multiply by 2, we actually square it, it's a coefficient, squared. I got 1 out of 9. Second mark out of 9. They told me Kc is 004. There's your second. You've got 2 out of 9 and you've got everything missing in the numerator and denominator. Isn't that nice? That's nice. If you don't know how to fill the table, put your own values, your birthday, the month you were born, the year, whatever it is. Substitute something, you get the 2 out of 9. If you leave it blank like this, you get 0 out of 9. Put some numbers there and square it 2 for HI. You get 2 out of 9. But remember, to pass, you only need 3 out of 9. Eh? 3 out of 9 is 33%. So let's get our pass first. Right, ladies and gentlemen, I need some help. That's all we're given. We've got our 2 out of 9 and we're stuck. The entire table is blank. There's my 2 marks. There's no other information given. We know the volume, right? The volume is 0.5 dm cubed. It doesn't fit anywhere in this table because this table must be in molarities or mole per dm cubed. I've got no other values. What is your strategy? When in doubt, leave it out. No. What do you do? Well, you got 6 unknowns and you need to solve for the concentration of these 3. You need these 3 urgently. Have you all done one like this before? No. Well, now I'll tell you. You let the change column, see this column here, this row here, equal to X. Anywhere here you put an X. Now, ideally, I like to put the X where the ratio is 1:1. You see, if I put the X here, then if the ratio is 2:1, if that's X, isn't this must be half X? Because when I double this answer, I must go back. Or when I halve this answer, I must go back there. Makes sense? Now, half is that F word, fraction. And we know how bad your maths is when you're solving fractions. So I prefer to put the X here, but the ratio is 1:1. If X moles are made here and the ratio is identical, how many moles are made here? Also X. How many moles were used up here if the ratio is 1:2 going backwards? 2X. Now this is a reactant. It is used up. So you take your pencil and you put a small minus sign there. So 1 minus 2X is your concentration at equilibrium for HI. These are products. It's on the right hand side. Put a small plus sign. Put a small plus sign when they're products. 0 plus X is X, molarity. 0 plus X is X molarity. And suddenly from a blank table I have 6 values. Now people say, but sir, these are all X. So what? You have a mathematical genius of a brain. You solve it. So we go back to our KC. It's a pity it's on a different screen now. Okay? Right? Our KC, okay, we have to move this thing, unfortunately. Our KC is H2 concentration at equilibrium, which is X, times I2 concentration at equilibrium, which is also X, divided by HI squared. Now, HI is that one. So it's 1 minus 2X all squared. Becomes a bit of a nasty thing in maths. 1 minus 2X all squared. And then you solve for X. And X is equal to 0,143 moles per dm cubed, which is equal to the concentration of H2 and I2, isn't it? Because it was called X. Go back to our table. It was called X. So now I've answered the question in terms of concentration. Right? What I'm worried about is, learners, how do you solve for X here? You notice I just put the answer. I did it in my head. You think I really did it in my head? Maybe I did, maybe I didn't. There's a calculator that's got the solve button. Do you all know about that calculator? You can type this as it is and press solve for x and it comes out in the next line. Now if you don't have that calculator, how are you going to get an answer? Well, you better get one calculator, borrow one. Or you square root the whole thing on the left, square root the whole thing on the right and cross multiply and solve the long way. Is that clear? That's the only way you're going to do it. So I expect you to get this calculator, yes? What it says? 0.3 recurring. That's strange. That means the national memo was wrong. Because this is a memo. No, you cannot accept a negative value. You can't have a negative concentration. The memo is right. The memo can never be wrong. This thing was passed nationally. That's the answer. Negative concentrations are ignored. There must be two values for that x. It's a quadratic. Okay? So that's your answer. Then the examiner asked you, he didn't ask you for the concentration of iodine, but rather he asked you for the very tricky, clever examiner. They're checking comprehension. They asked you to calculate the number of moles. So I've got concentration here. I've got concentration. So you simply say number of moles is C times V, 0,143 times, and there that volume that we wrote initially, half a liter, comes into play. And you get 0,072 moles, I think. And that is your final answer for 9 marks. Okay? Right, this is my answer. I will show you the memo now because the memo is much smaller. Okay? Now, I'll just show you the memo if you didn't do it in concentrations. If you did it directly in moles, remember I said you have to first change it to half a mole. See your fractions at the end here. Now see the fractions in the entire equation. Imagine trying to solve this thing using cross-multiply method with your brains. It's going to be challenging, isn't it? You're going to take over half a page to get to this answer. Make sense? So when you come up with this kind of scenario, put your table, your rice table in concentrations, not in moles. Because these fractions damaged you. You get all right, you will miss this mark. What I suggest you do is if you can't solve it, let's say you couldn't get this answer where my question mark is. How much out of 9 will you get? If it's a 9-mark question, you got this missing. You put equal to and you can't solve it. You get 8 out of 9. So don't strike it off. Is that clear? If you couldn't solve it but you know your entire table is right, don't strike it off. Now this is the scenario I did. Right? See how easy my table looks. There's no fractions. Isn't that short and sweet? And you can find the square root on both sides because these are perfect squares. Square root of this side, square root of that side, and solve. And you get the answer for x. All you got to do is the extra step and convert it to moles. Number of moles is C times V. Now which method you prefer? Option 2 or option 1? Ladies and gentlemen, it all depends on your mathematics. All depends on your mathematics. How many of you are copying this one down? Right now? Nobody. You took my one. Okay? If you prefer this, your teacher told you do the entire ratio, initial change, equilibrium, moles, and then divide by volume here. This is where you divide it by volume. See? It said it divide by half here. You divide it by the volume. Because moles divide by volume give concentrations. This goes in the case C. Okay? These three do not go in the case C at all. When you're dividing by volume, that's the case, that's a concentration. If you prefer this and you solve this and you get stuck for the answer, leave it blank, you'll get 8 out of 9. You can take a guess, x equals 5 moles per liter, whatever, and just leave it. You lose that tick only, but get the other 8. Clear, all of you? Right? This is a level 3 question because you have to put X's in the boxes. Okay? Level 4, you haven't seen yet. Level 4, you haven't seen in March. You haven't seen in June. You haven't seen it in your trial. Your trial paper 1 was easy. Easy rice table you all had. The trial 1 was easy. This one is much harder. There's X here. The level 4 one, I got at my house. The level 4 ones are in the June papers of the last 3 years. The national June papers. Go and have a look at them. Okay? They're very challenging. I suggest you look at them after mastering these easy ones. Don't look at that level 4 until you haven't mastered this. Right? And that's the end of chemical kinetics. We now come to question 7, 8, and 9. Question 7, the favorite question again of learners. Acids and bases. It was interesting. Acids and bases. Right? You have to know your acids and base theoretical questions. There are a lot of them. Right? I have used an acid-base question in this context here. That's got a lot of theory and less level 4. Because I find that many of us are losing a lot of marks on a level 4, and then we try to get these easy marks and we lose it as well. So I'd rather get 12 out of 18 in acids and bases, lose the 6 marks and maybe get 2 out of 6 there, and get 14 out of 18 and get a B or an A in acids, then go and try get all right and get 1 out of 18. Let's get our theory right. The underlying statement, this is no more marked correct, by the way. If you define a weak acid as ionized incompletely, they're marking it wrong. You must say an weak acid ionizes poorly in water to release H3O plus ions. To release H3O plus or H plus ions in water. Right? Last year they did not mark this right. The children lost a mark when they wrote incompletely. And this year they want to see this part here. To release H plus in water. You all are not writing that. Right? So, the underlying term means it's a weak acid. Right? A solution of ethanoic acid has a pH of 4. So, ethanoic acid ionizes poorly to release H plus and CH3COO minus in a ratio of 1:1:1. What that means is the concentration of all these, or in this case it won't be, it's a weak acid, right? 1:1:1, right? They want you to calculate the concentration of the H plus ions. Now because these are 1:1, it'll be the same. So we say pH is equal to the negative log. Please copy this properly from the data sheet. It's not H3O, it's H3O plus with a closed square bracket, not round brackets. You guys are selling yourself short by poor copying data. Please, the pH is 2 or 4 is equal to the negative log of the H3O plus ion. And then you work it out. The concentration of the H3O plus in your calculators, and it will give you an answer. I don't have a calculator on me at the moment. 1 times 10 to the minus 4. Yeah, that's right. Moles per liter. And you should get 3 marks. Equation, substitution, answer with unit, and square brackets. You can't leave out that square bracket even, because the memo won't have it left out. Please, copy correct science. Now, once again, this is the pH of an acid. You haven't seen pH of base question come out end of the year. Right? Now we come to our difficult, so-called difficult question. A standard solution is a solution of precise concentration over a long time period. They could ask you to define this. It's a precise concentration over a long time period. It's prepared in a 250 cm cube flask. So we don't know what they prepared, how much, we only know the volume. During a titration, 12.5 cm cubed of this base neutralized 25 cm cubed of 0.16 moles per liter acid. So we've got quite a bit of things here. We've got VB, we've got VA, we've got CA. We've got 3 values. That's quite nice. What's missing is the concentration of the base. That's missing. Right? So 7.2 going on to it. 7.2. Right? The balanced equation for the reaction is ethanoic acid reacts with strong base. Oh, by the way, we must know this. Weak acid, strong base. The moment a weak army fights a strong army, the stronger army wins the battle. The strong base will win. So this becomes a basic salt. Strong must win, beat the weak. Am I right? So this is a basic salt because it was a reaction between a strong base and a weak acid. The weak acid was overpowered and hence the products become basic. Got it? And because these two have different strengths, that salt will undergo hydrolysis. You only get hydrolysis when one of these is weak. If they're both strong and both weak, no hydrolysis. If you got a strong acid, weak base, you get an acidic salt. So acidic and basic salts are the only salts that undergo hydrolysis. Now, why am I stressing this? There's the question here. 7.4 is hydrolysis. 7.3 is hydrolysis. And it didn't come out in your paper in March, June, or your September. It wasn't there. It was in multiple choice. So I'm telling you, end of the year it will be there. Right? So, let's get our first 2 marks. What is an Arrhenius base? Arrhenius base is not Laurie Bronsted. Proton donor, proton acceptor. Arrhenius base is a base that is a substance that releases hydroxide ions in water. Right? A chemical substance that releases hydroxide ions. Please do not write the formula. You can write the formula in brackets after that. So, Arrhenius base, right, releases hydroxide ions in water. And acid, Arrhenius acid, releases H3O plus ions in water, or H plus ions in water, right? 7.2.2, calculate the mass of potassium hydroxide used to prepare the solution in the 250 flask, right? 7 marks. Now, obviously, when we teachers teach you guys, the first thing we tell you is select the 2 chemicals that are relevant to the calculation. And the relevance in this case is, let's go back to what they gave us. They gave us VA, CA, and VB. It's common sense that I got to select the acid and the base. It's common sense. So you select the relevant 2 chemicals. Now I'm coming back to my white page. This was number 7.2.2. 7.2.2. Right? Acid is to base. Some of us don't know which is the acid and base. That's frightening. The acid is ethanoic acid. And the base was KOH. And don't write A and B, write the word acid and base. And the ratio was 1:1. Please, when you are doing any stoichiometric calculation, select your 2 relevant chemicals with the mole ratio. Please. You're going to get a mark for this selection eventually when you get all wrong. The examiner is going to look here. Because if you don't have this thing, you're going to get 0. I'd rather get 1 out of 7 than nothing. or maybe 2 out of 7 or 3 out of 7. But if you left the ratio out, you'll never get that 3 out of 7, I'm telling you. So we write acid CaVaNa, CbVbNb. And now we go and pick our values from the data given. So we go back to our questionnaire, okay, which is here. Right. Va is 25 times 10 to the minus 3. Why? We go back. It's cm cubed. Deadly to leave it in cm cubed. Vb, 12.5 cm cubed. So Vb, 12.5 cm cubed. Ca, 0.16 molarity is unknown. Right, let's come to our answers now. So the fifth part of your calculation, stoichiometry, work from known to unknown. I think I've got more knowns here. I'm going to work on this side. N. Hey, many of us, I need to do this. You see, ladies and gentlemen, the data sheet's got C is equal to N over V. That is of no help to you in this question, because you need to start with which letter? N. What the data sheet started with. And now you're in trouble. So you'll try and figure out, is NC divided by V, V divided by C, C times V. I'm going to do some bad maths. So please learn this triangle. If I want N, block it off, it is C times V. If I want V, block it off, it's N divided by C. If I want C, it's N divided by V. You're supposed to know all this as matrix. This is done in grade 9, the triangle way of solving things. Grade 9 work this. How to use a triangle to get your maths right. You can't be putting the wrong formula here. N equals CV. You can't put NC divided by V here at grade 12 level. It's just unacceptable. And this is for the acid. Now why am I writing acid? Some children take that 12 and go and put this side. That's the base, man. This is the base. You can't take base values and put an acid section. So C times V, there's it here. 0.16 times 25 times 10 to the minus 3. And it's going to be a very funny answer, because these are small values, people. These are very small values. The answer is 4 times 10 to the minus 3 in scientific notation. But what is the ratio of acid to base? Identical or non-identical? So therefore, the number of moles here can be transposed here. 4 times 10 to the minus 3, because you've shown the examiner the ratio above is 1:1. Now, if you had the answer wrong here, but you transposed your wrong answer and put it here with the identical ratio, now he's going to give you that mark for 3 out of 7. 1, 2, 3. You got 3 out of 7, you didn't fail. So once again, ladies and gentlemen, when you see the level 3 and 4 question in the exam, don't run from it. Target it. You still haven't solved this thing, but you've passed. Better than leaving blank. And now they want mass, or before they want mass. Yes, they want the mass in 250 cm cubed. Right? And let's go back to the question. Calculate the mass of potassium hydroxide in 250 cm cubed. When we worked out our number of moles, we got the number of moles in 12 cm cubed. How do you get the number of moles in 250 cm cubed? Anybody knows? There's the answer, number of moles in 12.5. In 250, how do we get it? You divide these two, correct. You'll say number of moles total is equal to 250 divided by 12.5 times 4 times 10 to the minus 3. What's 250 all over 12.5? Somewhere here. 250 times 12.5. Or divide by 12.5. What is it? 8. 20. 20 times 4 times 10 to the minus 3. 20 times 4 is 80 times 10 to the minus 3 moles. So your total moles is this. Therefore, I can find mass total. Mass total is equal to N times molar mass, which is N is that now, 80 times 10 to the minus 3. The molar mass of KOH is 56. Check the data sheet. Right, that's 39, oxygen 16, hydrogen is 1. Add the molar mass. And what is 80 exponent negative 3 times 56? Learners, 4.48 grams, I think. Right? Okay? Now, let's suppose you did not do this. You forgot to look at how many times bigger this volume is compared to that volume. You didn't know it's 20 times bigger. You went directly here. Instead of 80 here, you went and put 4 times 10 to the minus 3 times 56. You get 5 out of 7. You will get 5 out of 7 if you forgot this step. If you forgot that step, you'll get 5 out of 7, because the only mistake you made is if you forgot to multiply it by 20. Am I right? If you multiply your answer by 20, you'll get the answer. So don't give up. Don't leave blanks. This is a very important thing, this, how to find the total moles of something. It's a very useful tool, this, using the ratio of the total volume and the volume that you extracted. That's the total volume. That's what we used, VB. It's a very useful tool, this, to get total number of moles in the original container. Very useful indeed. Of course, there are many methods to solve this. Now, I don't want to scare you, right? The marker must know all 7 methods, right? There's option 1, 2, 3, 4, 5. There are many other options too. People do it with graphs and so on, right? So this is option 6, option 4 and 5. I took option 3. I like option 3. I teach with option 3 as well. There's my option, right? I don't teach this method of solving to any learner, because if you don't know what you're doing here, you'll never get this thing right. This is only for 1:1 straightforward classwork and homework. Don't use this, I suggest, in the exams, unless you can perfect it. You rather break it up into number of moles acid, number of moles base, and so on, like what I've done here. You can get more marks this way, because with this method, you make one mistake in these options here, in these steps. One mistake, you're gone. You're getting nothing. Okay? That's acid and base gone. We now move on to redox reactions. Redox reactions. Now, unfortunately, ladies and gentlemen, in redox reactions, there are... Oh, I didn't finish the question, sorry, before I go on. I only finished the calculation. Let's do the English. The hydrolysis of the salt. Now, the good thing is the examiner gave us the salt. The examiner gave us the salt. Let's go back to the question. There's the salt here. Potassium acetate. Potassium acetate. So I need to write that down. Before we write that down, let's get the 1 mark. Will the pH be greater than, will the pH at the end point be greater than 7, smaller than 7, or equal to 7? We already said it is basic. So the answer is greater than 7. Now, unfortunately, if you got this wrong, you're going to get 0 here. You can't put less than 7 here and get full marks here. That's a bit absurd. Explain your answer with the aid of a balanced equation. So I'll write the balanced equation here. When you take a metal ion with a non-metallic ion, the non-metallic ion always, the anion will ionize with water. Hydrolysis. The exception is the cation ammonium. This is the only cation that reacts with water. The rest of them are anions. So hydrolysis is the reaction of the ions with water in a salt to produce fresh air. Now you have to tell me what that is. You can't by heart these things. You have to work it out. Is there any hydrogen to donate here? Yes or no, where the upside down V is? Is there any hydrogen to donate? So this guy is going to accept a hydrogen from there. So if the hydrogen from there comes here, that becomes CH3COOH. Because it doesn't have any hydrogen ion to donate. If that H goes away, can you see there's only one H and O left? Now you can't write HO, HO. It's the other way around. It's hydroxide, people. And there's the strong base here. This is the reason why that salt is basic. It's basic because its negative ion results in the water in there becoming basic. Hydroxides are released. Okay? So please, there was no, you're using Laurie-Bronsted theory, by the way, here, to get your two products. Now, this thing must come out in the exam. Right? It came out in your paper, you had two answers. You want me to do another one? Right, let's do the ammonium one. I'll do it down here. Right? NH4 plus is a salt of ammonium, the cation of ammonium chloride. Right? That's Cl minus, sorry. That's ammonium chloride salt. The cation here is the one that undergoes hydrolysis plus water. Now, if I donate an H from here, isn't this becomes NH3 plus? Have you seen such a formula in your life, NH3 plus? No, then your answer is wrong. You can't donate H's from here. You can donate H plus from here. If I donate an H plus from here, what does this new answer become? Have you seen that before? Good. So this donates H plus. So this had to be an acid 1. And this is its base 1. Correct? So if this was an acid, a donator of protons, what must the water behave like? Can you have acid on the same side? Never. The water has to be a base. And the base is a proton acceptor. So you gain an H plus. And this becomes H3O plus as a product, which is the strongest acid in the world. Hence, salts of ammonium will always be acidic. Whether it's ammonium nitrate, ammonium carbonate, ammonium chloride, you can put anything here. Nitrate, chloride, sulfate, anything. Right? It's all going to be an acidic salt because the ion will hydrolyze to release H3O plus. Salt hydrolysis will be in your paper. Right. Question 8. The electrochemical cell represented in the cell notation below is given. Zinc elemental, it's a solid, became +2. From 0 it increased to 2. The oxidation number increased. That is undergoing oxidation. Zinc underwent oxidation. Obviously, if zinc underwent oxidation, X plus 2 underwent reduction. Therefore, it is called the oxidizing agent. And zinc underwent oxidation. Zinc solid is called the reducing agent. These are things that must go through your mind before you look at this graph. You have to know this. I can't spell it out to you, the value of the standard cell notation. If it's standard conditions, that's called standard cell notation. It's not called E naught value. It is not called the overall net equation. It's called standard cell notation. You must know the difference. And because you know this is the reducing agent undergoing oxidation, that has to be the anode. That has to be the cathode. But you make sure when you're deducing all this, this word is there. Because in one exam they did this to the learners about 20 years ago. They did this. This was nasty. This was really nasty. Right? And they put some other metal here, maybe copper, 2 plus copper. Right? From 2, this is 0. That's reduction, isn't it? A decrease in oxidation number. From 2, what is this? Also 0. That's also reduction. But they did not say that this was standard cell notation. They said this is a cell notation. You had to first reverse those two before you started the question. You think they'll do that nasty thing to you guys? I hope not. So make sure when you see the word standard conditions, this is standard notation. Look for that word. Okay? And because that's standard conditions, this is the anode and that's the cathode. I worked out my entire battery without even looking at question 8. Now I know the reducing agents, the oxidizing agents, the anode, the cathode, the place where oxidation occurs, that's where it lost electrons. The cathode is the place where it gained electrons. I can look at the data, which is now level 3. And what this data tells me, as the concentration of the X plus ion is increasing, so is the EMF of the battery. Can you see it increased from 1.07 to 1.1 when the concentration is exactly 1? Now when the concentration is exactly 1, isn't that the standard concentration? Yes or no? So this is the standard E naught value of this battery. How much is it? How much is it? 1.11. So you say the standard E naught of this battery is 1,11 volts. And we know the E naught of zinc, I can get it from the data sheet. So I can find the E naught of the unknown one by subtracting the 2 or adding the 2 depending on the maths. Yes? And that is how you start this question. Before you start, you make sure you recognize that that concentration, this coordinate, is the coordinate at standard conditions. And this EMF is the EMF of the battery. There's it, they tell you that. So this practical was done in a high school where the concentration of the cathode was varying while the EMF was changing. Can you see that? They kept changing the ion concentration at the cathode. That is what you need to understand. And now this question becomes a joke. Right? For this investigation conducted by the learners, write down the dependent variable. I know all life science teachers say the y-axis is the dependent variable. I don't like that. Right? Does concentration depend on EMF or EMF depend on concentration? Thank you. That's how you do it. EMF is the dependent variable. Number 2, name an instrument. This is so sad if you get this wrong. It's embarrassing. Very sad. You didn't do homework in your life. Number 3, the component that ensures electrical neutrality is a salt bridge. See, all this is theory. 100%, you must get all right. Values of the 2 standard conditions. Concentration of solutions is 1 mole per liter and the temperature must be 298 Kelvin. They like asking this. Write down the conclusion that can be drawn. Now we go to the table or go to your graph. As the concentration of the cathode ions increase, so did the EMF of the battery. An increase in concentration of X2 plus increases the EMF of the battery. EMF is directly proportional. Wrong. This is not a straight line graph again. You rather write simple English. An increase in concentration of the X2 plus ion increases the EMF of the battery. Take it from the shape of the graph you recognize. It's increasing with X and Y. Next, identify electrode X with a calculation. Right, that we come to our page once more. Right, what do we know? Right, what do we know? What do we know? We know the E naught of the cell is 1.10 volts. We also know the E naught of zinc in the data sheet. I don't have a data sheet here. It's negative something. Just check your data sheet, E naught for zinc. Negative. Table 4B, zinc. That's it, 0.76. But we also know that when we did our detailed study, zinc is the anode. And that's what we need to know. It is the anode. Therefore, I'll take my equation from the data sheet. You can take any one of them, standard equations. I'll say E naught cathode minus E naught anode, which is 1.1, is equal to the cathode, which is X. I don't know. E naught of X. Minus. Now this minus sign is not that. This minus sign came from the equation. The anode got the minus sign. Do you understand? Yeah, so please put brackets. Now the rest is maths. 1.10 equals E naught of X minus times minus plus 0.76. Then take this, that side becomes minus 1.10 minus 0.76 equals E naught of metal X. And what is the answer? What's 1.1 minus 0.76? 0.34 volts, which are left out in the trial. I marked it wrong. No volts equal no marks, which is the E naught of X. Now you go to the data sheet and look for this value. And which metal it is? Copper. And you should get 5 marks for that. 1, 2, 3, 4, and don't forget the formula. The data sheet formula 5. If these zeros are not cancelled, like me, and these words are not written in full, -1, negative marking. Remember that. Negative marking rule will apply. Remember that, please. Copy from data sheet perfectly. Okay? Right, coming back to our answers or questions. Right? Write down the net reaction of the entire cell. Now that we know it is copper versus zinc, you'll reverse the zinc electrode. Right? Right? Zinc electrode. Zinc becomes Zn2 plus, releases 2 electrons. Remember, I'm doing the overall reaction. This is my rough work. This is not the answer. You must be careful in the exam. Write the word rough work. And the copper 2 plus gains 2 electrons to become elemental solid copper, because you said it was a cathode, and that's reduction, that's oxidation. What do you notice about the electrons in both? Are they identical or non-identical? So we don't need to multiply by anything to make a common factor. So we simply call that equation 1, equation 2, equation 1 plus 2. And now you write and show the examiner, this is the net equation. Zinc cannot cancel copper. So zinc plus copper 2 plus. The electrons there and there will cancel. Don't cancel it, just leave it out. You know in your mind you cancelled it. Becomes Zn2 plus Cu solid. And this was the answer for 8.4. Now you go number it 8.4. 8.3 was there. Right? Let me just show you. 8.3, you wrote your answer. Rough work, 8.4. If you put 8.4 there, we strike off this and mark that line. We'll mark this. We'll mark the first option. But your answer is there 3 lines later. Because you numbered it poorly. You wrote 8.4 in the first line when you're supposed to write it in the answer the examiner's question. He asked for net equation. Tell him I'm writing net over here. Is that understood? They are very technical when they mark metric papers. In class we can be lenient. In the national paper, you can't. Right? Because the marker can get into trouble for marking wrong things right. Okay? And that is galvanic battery done and dusted. Now we do the easiest thing of all, electrolytic batteries. Question 9. Right? Now this is the concentration or electrolysis. Yes? Oh, did I use 1.11? Oh, I didn't see the last digit. Sorry, just change it then. That means I got 0 marks. Why? 0.35. Then you take the closest one. Oh, I know. So what you're telling me indirectly is that I actually corrected the memo or the question paper. I'm very good then. Sorry, there was an error there. Let me go back to that question quickly. Okay, yeah, there it is. Just change this thing, please, ladies and gentlemen, to make 1.10. It should have been 110. Otherwise, you don't get the E0 value. But if that happens in the exam, take the one that's closest to that metal. Closest to that metal. 35 and 34, it's still copper, we'll take it. Right? Question 9. Right, ladies and gentlemen, this is called theory. You should not be having any problems with copper refining. Number 1. Number 2, NaCl electrolysis. Number 3, electroplating. Shh, people please. Remember yesterday, let's have some respect for each other, thank you. And number 4, electrolysis of any ionic compound. Example, PbI2 for example. Because we teach CuCl2 in class. They can set PbI2. Now I'm going to show you how easy it is. Notice PbI2. There, write it. That's what will come out. When you pass electrical energy, what you see is what you get. You get lead solid and iodine gas. Just like copper chloride. You electrolyze it, you get copper solid and chlorine gas. So you mustn't get frightened when they give you a halogen with a metal. Hey, we didn't do it in class. All you've done is, I've replaced the copper with lead and the chlorine with iodine. Same answers. The cathode will always increase in mass, which is the metal. The anode will always reduce in mass. The anode will always have the gas. Always. Doesn't change. So don't get frightened when you see a different ionic compound, but you were taught this. Now this one, you've got no excuse. NaCl, electrolysis. There, teacher gave you the notes, you must learn and by heart it. Learn and by heart it. Right? Finish and clear, no stories. You want to by heart something? NaCl solution is NaCl plus H2O. What will it produce? Take a guess. Hydrogen, chlorine, and NaOH. That is your net equation. Right? Then you can see Cl minus became Cl2. It increased. So this chloride ion underwent oxidation. And the water undergoes reduction because this is 0. Hydrogen is plus 1 there. You learned the whole battery from one equation. You learned the whole battery from the equation. What's there to learn is the English, the theory. And now you get full marks for the question. Look how easy this becomes. Define the word electrolysis. Electrolysis is a process where electric energy changes to chemical energy. Finish. Electric energy is supplied, you change it into a redox reaction, chemical energy, done. Chlorine gas is released at X. Write down the letter where oxidation occurs. I just told you it occurs at the anode. And at the anode, chlorine gas comes out. So it's X. See how easy it becomes. X is the answer. The half reaction at Y. So if X is the anode, Y will be the cathode. The water equation in the data sheet. H2O gains 2 electrons to becomes 2OH minus plus hydrogen gas. Do not ever put a double arrow when you select this from the data sheet. The moment you put a double arrow, you get naught. Right? In which direction will electrons flow? It is always from anode to cathode, which is X to Y. It will never be anywhere else. Always from anode to cathode. Remember this. This is all memory. You have to learn this. Anode to cathode. Okay? Write the balanced net equation. Now see how clever you are. There it is. You wrote it initially. You by-hearted it and learnt it. You got full marks. You write that with no working, I give you full marks. Isn't that nice? Isn't that nice? Cut and paste in the brain, please. So these net equations, learn them well in these 4 reactions, please. Learn them well. This one is so easy. The answer is in front of you. P, B, and I2 separate. So easy. I hope you all thank me end of the year. Right, next. How does the... Now there's the thinking question. Level 3 for 2 marks. How will the pH inside this battery change? The pH, the degree of acidity, will pH increase, decrease, or remain the same, no change? How will you know this, learners, without even seeing this battery as a practical in high school in your class? You do know, the answer is right in front of you. What did you make here? Acid or base? You made a base, the pH will increase. The pH will increase. Where's it? Give a reason for your answer. I just showed you the reason. A base was produced, therefore pH is greater than 7. Make sense? Make sense, all of you? From salt water in the sea, you produce soap water with chlorine gas and hydrogen gas at the anode and cathode respectively. Understood? Make sense? So learners, online and in the audience, the only way for you to maximize your credit in this kind of question is you have to learn your theory well. Now this question has come out repeatedly. It may come out again, they might ask backward kind of questions. For example, they didn't ask you to label the anodes and cathodes. They didn't ask you which is plus and minus here. But now we can tell you that which is plus and minus. If that's the anode is always positive in an electrolytic battery, but negative in galvanic. That's negative. The anode is always positive. Now they may ask you, what is the polarity of this battery per electrode? You see? The electrons flow from the anode to cathode, so it will flow to the right, that way. They can ask you questions of that nature because they're not here. What is the concentration of the solution? With time, does the concentration change? Right? Does the pH change? Well, the answer is yes. Okay, the pH does change, it actually increases. Right? If these rods are made of carbon on a bigger scale, what happens to these carbon rods with time in industry? These rods will decompose. The carbon gets used up to make carbon dioxide later on. And then it's a costly exercise to replace the electrodes. Okay? So please go and learn your theory. It is imperative that we learn it. And that is the end of our chemistry session. We will now start the physics. I know it's still, we've got a few minutes before lunch, but I need to start the physics because it's also a 9-question paper and we need to finish it timeously. Give me a second to get rid of all these items that I used because it's now a distant memory of ours. I hope not. And we now look at the physics booklet. Okay? For my audience in front of me, it's the first page, I think, of your booklet, the physics booklet. Right? It's the first couple of pages. Those online, you have it emailed to you. And this is the document that we are looking at now. Right? It's the term 4 revision document. Right? Physical Science Paper 1. It is a little longer than 150 marks because I picked a few extra questions that I think that learners struggle in. Okay? And let's look at the multiple choice. I want to at least do this multiple choice in 10 minutes before we go for break. Right? The work done by a non-conservative force. Now that's a definition. This exam paper I set in a previous school where I taught. Right? The work done by a non-conservative force, is it part dependent or part independent? Non-conservative. Dependent. So the answer is definitely B. Number 1.2, a little bit of maths. A snooker ball with a velocity v collides head-on with another snooker ball of the same mass at rest. So you got one ball, right, with a mass m and a velocity v. So its momentum is mv of one ball. The other ball is at rest. So it's got zero momentum. Okay? If the collision is elastic, the velocity of the second ball after the collision. So when this ball collides with this ball, it will take off. What will happen to ball number 1? Roll or stay at rest? Roll or stay at rest? If it's elastic, it'll stay at rest because this transfers all its energy perfectly to the second ball. So what must this ball's takeoff speed be? 0, it can never be 0, can't take off with 0. Half V, V or 2V? Correct, V. If energy is conserved, mass is conserved, velocity is also conserved in this case. It's perfectly elastic, V is correct. Number 3. Now, maybe some of you have seen this one before, right? This is a truck up an inclined plane of 10,000 kgs, pulled up 120 meters at an angle of 120. Which of these statements can determine the work done by the force of gravity or the work done by weight? A, B, C, D. Now, this is a level 3 question. If you try all three or all the options, you're going to get bamboozled. What? Have you seen such a thing before where not a single angle is cos 0? And remember, weight acts downwards. The truck is sliding with a force F uphill. The 20 degrees is the angle of the hill. How did they incorporate that 20 all over here? Look at here. Cos of 20. This is W parallel there. And the work done by W parallel is W parallel cos delta x, which is W parallel cos of 180 times 120. But that's not here. Cos of 180 is this W parallel. 10,000 times 9.8. No, W parallel is 10,000 times 9.8 sine of 20. The sine is missing here. Agreed? So C is definitely out. B is absolute nonsense. A is nonsense. The answer is, but look at the angle I put. Now you think about it. Where did I get that 250 from? I don't know. Say it, I don't know. The answer is D. Right, I'll show you quickly. Before we go for lunch, I'll show you quickly. This is the normal. Remember, your object is going this way. Weight is down here. The weight has swung 90 degrees from there. 90. Swung another 90. What's 90 plus 90? Plus a little bit of this amount here to come straight here. Now, if you did grade 10, or sorry, not grade 10, grade 11, your inclined plane, do you all remember? It's something that you'll need to remember from grade 10, grade 11. How did we get our components? That's 20 degrees. Right? Your teacher must have drawn a dotted line there. That's 20 degrees. Corresponding angles are equal. That's 90. This has to be 70 degrees inside. Agreed? This parallel line, then your teacher completed the rectangle around this weight. And if it's that 70, this angle is also 70. Get it? So there was the force. Your weight actually rotated 90 plus this 90 plus that 70 to come straight down here. Make sense? What's 90 plus 90? Plus 70 is 250. So if you take cos of 250, you swing the weight vector 250 degrees to match this, you get the answer for the weight, work done by weight. Nobody teaches this method in high school to find the work done by weight. I just put this as a level 4 for my ex-school to be nasty. Right? So if you see this in the exam, just select it, okay? Do not use this method to solve for WW. And we will now take a break for lunch. Right? I'll see you in 45 minutes time to continue this paper. And by 5 to 3 we should be finished, hopefully with God's will. And myself, obviously. Thank you, online audience and audience in front of me.
And that is Mr. Nikesh there, who is the facilitator for the workshop that we are currently doing now. We will take a short breather, and obviously we will be back at 1 o'clock, where we will be talking to few students who are currently on the ground at Falaah College in Durban, do make sure that you visit the Awqaf SA website, whereby you can get more information as far as these workshops are concerned. But for now, we take a short breather. We will be back at 1 o'clock, where we will be talking with few students who are on the ground at Falaah College in Durban.
Khalid? Khalid?
Yes, yes.
We have some learners lined up for the interview.
Okay, you can send me the information on the WhatsApp.
Okay, I have 2 learners. Let me. Khalid? Khalid?
Wait. The burgers are here. The burgers are here. And I brought a nice bowl. Okay.
Khalid, we can't hear you. Switch to the side camera. Hello, Khalid. Khalid.
You still
The
cannot hear
learners
me.
are ready for you.
You still cannot hear me.
We can hear you now. You can go ahead.
Now I believe on the ground. We have Shakiru Sal. Shakiru, we are glad to have you here as far as the break time. Quickly tell us what sort of encouraged this one.
Khalid, I think we should abandon this. We can't hear
Yes.
you. The learners
Yes.
can't. Learners couldn't hear you. Please ask your question again. We are interviewing the young lady first. What is your name? You are interviewing Shakira Salim first.
Shakiru Salimu, my question was what motivated you to be here today?
What motivated me to be here today was I saw this as a very good opportunity for me to better myself, to increase my ability to answer certain questions that challenge me.
Now, Salimu, we know that students are familiar with Awqaf SA having a physics. Did you attend some of them?
Can you please repeat? Can you please repeat your question?
I'm saying that most of the learners are not aware with Awqaf SA having, there's the physics workshop. Um, how did you come to hear of the physics workshop?
This is not the first time for me to be. Yeah. I heard it from school because Awqaf SA has been a website that we always use whenever we used to study for mathematics. So that's where we heard of the physics workshop.
Okay, very well. Of students I talk to, I always ask them as to what exactly do they want to become, after they finish, their schooling. But I see Salimu has ran away from me there. I believe now we have Ntlakani Pomata, from Siyabonga Secondary School. Nhlakanipho, welcome to Awqaf SA.
Thank you for welcoming me here. It's a great pleasure to be in this workshop.
Now, Nhlakanipho, tell us. Has the workshop met your expectations? Coming here, your main expectation.
Can you please repeat the question?
I'm saying, coming to this workshop, has it lived up to your expectation?
Yes, it definitely has, because it's I have gotten like some small knowledge that I didn't have initially from the get-go, but I thought that coming to this workshop has been beneficial, absolutely, and I know I got to know some new formulas from physics, which will help me going forward into the final examination.
Now, Nhlakanipho, after you finish in the schooling, what are you looking forward to becoming?
Like in the varsity.
Yes, your career.
Or I was looking to be like I was going to go to physiotherapy, physiotherapist in one of the varsities, you know. So I needed these physics marks for me to get in the varsities.
Are you the only one at your school who wants to become a physiotherapist?
Can you please repeat the question?
Are you the only one who wants to become a physiotherapist?
Oh, I think, I don't know, but I think I'm the only one. But I don't know from the others. But I think I'm the only one. I don't know if they have the same also dreams.
A workshop like this, how can it sort of like
because like during the school year, I've gotten like a level 6, you know, getting to that 70%. But I think that that coming to this workshop will like help me get into that 80s, into those A's, which will give me the marks for me to get admitted into that university to do that specific course I want to do.
Thank you very much. Nhlakanipho Matha.
Thank you.
Secondary school in KZN. Now we are witnessing difficult, manage. We thank Mr. Khatri there for fixing the sound for us. And now I believe that it is break time for those of you who have just joined us. Do make sure that you stay with us and wait for the lessons to resume. As we have said that the lessons will resume 1:15. We will make sure that Mr. Nikesh is there going on with the lessons for you. But for now, we will take a short break. I see it's difficult for me to keep on talking because of the audio issues that we're experiencing here. But that's it from me. From now, I will be back at 1 o'clock with your testimonials. Thank you very much.
In the year 2000, Awqaf South Africa was pioneered as an institute of Awqaf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa.
Hello there, my name is Maxwell-Boltzmann. I am in my first year of my undergraduate studies in natural science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Awqaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Awqaf SA has been greatly instrumental in me reaching my goals in matric. I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate.
Good morning everyone, my name is Maxwell-Boltzmann and I am the winner of the 2022 Awqaf SA Online Matric Maths Workshop competition. Yeah, that's quite a mouthful, but we'll get into that later. I just wanted to make this short video to encourage and congratulate the matric class of 2023 for making it this far. You have been in the schooling system for 12 years now, and it all comes down to this. We are at the end of the year, which means that finals are starting soon, and the time between now and finals is very crucial in that you have to work hard and make sure that you are comfortable with what you've been doing this whole year and that you're confident walking into that examination room. And I can say confidently that by attending these workshops, you bring yourself one step closer to reaching your dreams because they will do wonders to your marks. Only if you actively participate and ask questions. So please just make sure that you use them wisely because they can really help a great deal in your marks. And having great marks in matric comes with a lot of great rewards. And speaking of rewards, Awqaf SA is hosting a competition for the participants of these workshops. So you will have to send your final results and your June matric results to them next year in January. But you don't have to worry about that right now. Just be mindful of the fact that there is a competition that will be hosted by Awqaf SA. If you registered for these workshops, you will be sent an email after the final results are released. But just make sure that you enter the workshop when that happens. And finally, I just want to say good luck. Just grind. This is the final push. You're almost there. And I believe in you. You will make it.
And that's how we come back to you here at Awqaf SA as part of the physics and chemistry workshops that are currently taking place since yesterday and tomorrow. And you may have known that on Saturday we held the pure maths workshop for grade 12. There are more workshops that are coming, for your grade 11 and for your grade 10, as well as that we deal with grade 12, 11, and 10 as well. So do make sure that you visit Awqaf SA's website at awqafsa.org.za. That's where you will get most of the information as to the exact dates when those workshops will be taking place and where exactly those workshops will be taking place. We're very grateful that you have decided to join us and be with us here today. Today we are dealing with physics and chemistry as well. So do make sure that you are logged in up until 3 o'clock. The lessons will resume shortly at around 1:15. Do make sure that you send those comments coming. And let me read to you some of the comments that were coming from Anele Mufokeng, saying that informative lessons, meaning that he was enjoying the lesson there. And we've got Bavumile Kwala there asking which year is this. I believe he wanted to know as far as which module we were using. So for those who don't have the memo is on the comments. Do make sure that you visit the comments. You will find a link there. The memo is there. And then we also had Sine saying that thank you very much, sir. I believe that she could resonate, or she was enjoying the lessons there. We also had Cute Mia saying that hello from KZN. As we know that we've got a lot of people from different provinces, so you will get from now and then people who are communicating with us, like Priyanka Govender, they're saying that thank you very much for these sessions. Again, I have to say that we have the memo on the comments, so you don't have to ask us which paper are we discussing. The memo is there on the comments. I believe now we are about to go back to the lessons because Mr. Nikesh is there, and therefore I will give him the floor now to take the lessons away. That is Mr. Nikesh, who is going to continue with the lessons for today. I believe a lot of you cannot wait, to start the lessons. Therefore, we should give Mr. Nikesh the floor to go on with the lessons. Thank you very much.
Right, we're going to be back online soon. Just giving you a few minutes to get yourself in readiness, online learners and the audience. I hope you had a good lunch and everybody is well rested to tackle the next few problems, and hopefully we will finish on a high note. The last thing I looked at was 1.3 of a challenge kind of question on the work done due to gravity or the work done by weight. As I mentioned, that the option was not even included in the multiple choice. However, if you look at what I have done below this in purple writing, I say calculate the work done by the component of weight to match option D, and you see it will match. If you use the equation, work done is force multiplied by cos of the angle multiplied by delta x. And the force in this case is W parallel, which is mg sine theta. Cos of 180 because the object is going downhill. The weight parallel component is downhill, but the object is going uphill, therefore cos of 180. Multiplied by 120 meters of the distance traveled, or displacement, you'll get the same answer as option D. So that's another way of working it out to match. Okay? Now we tackle 1.4, which is in front of the audience as well on the first page. Right? We are doing the first 4 pages of their booklet, the audience. Okay? 1.4 talks about mechanics once again. Right? Which is the last chapter of mechanics, work, energy, and power. Now, the equation P is equal to FV, right, is actually PAVE, the average power, right? And this equation is used for objects only at constant velocity, right? As mentioned in the question as well. So, if you are asked a power calculation of a car, a bus, a truck, or a bicycle, and if they're moving at constant velocity, this is the equation in the data sheet to use. The average power is equal to the applied force. I always tell my learners to write FAP here, because many learners write the net force when it should be actually the applied force, which is the applied force of the engine of a vehicle, or the applied force of your legs on the bicycle pedals, or it could be any other kind of applied force. Tension could be an applied force if you're lifting a bucket of water, for example. So, this equation refers to objects at constant velocity to calculate the power of that object. F refers to, and there, since I just gave you the answer, it won't be A, it's not the net force or resultant, it's the external force applied to the object. So the answer is definitely B. It will never be used for the frictional force or the gravitational force. Alright? 1.5 deals with 2 different masses in a ratio of 1:3. One mass is triple the other mass in terms of labeled S and R. But they both have the same applied force or net force to these objects. Now, there's a long story here underneath these 2 isolated systems. The mass of S is 3 times that of R, as shown. When friction effects are ignored, the rate of change in momentum of S is called X. What is the rate of change in momentum of R under the same conditions? Now, what you are being tested here, candidates, or ladies and gentlemen, is the definition of this term, rate of change in momentum. Now, what is that as a single word? It is the net force. So, the net force is glaring at us, because if there's no friction in both conditions, there's a surface missing here, sorry about that. If there's no friction, the only force applied is force F to both cases. And if you look at the F's, they're identical. But the examiner called that force F X for box S. So it's called X instead of F for box S. What will it be called for box R? 1/9 of X, 1/3 of X, X or 3 of X, 3 times X. Now, if the force is called X, the force here will also be called X, because these forces are identical. It hasn't changed. So your answer here is C. They try to trick you with the ratio of the masses, but what you needed to understand is the rate of change of momentum is F. It is that. Because it's the only single force acting on the system. There's no other horizontal forces. Yes, there's weight and there's the normal, but these cancel vectorially when you're moving sideways. They cancel off. Okay? 1.6, these questions are becoming common now in all exam papers in provinces, where the gravitational law is not ignored anymore. They are setting it. So 1.6, two objects of masses m and 2m are shown in the diagram below, a distance d apart. Which one of the changes will allow for the greatest increase in the gravitational force of one on the other? So the gravitational force equation is F is equal to G m1 m2 all over r squared or d squared. Now that means the attractive force is directly proportional to the product of the masses, but inversely proportional to the square of the distance between their centers. Now obviously if the distance between them is small, your answer becomes very large. And if your masses are big masses, they're directly proportional to that. So the larger these masses, when multiplied, you're going to get a massive force as well. So we are looking for those answers in our alternates. Doubling the larger mass could make it very high because it's directly proportional. Halving the mass will also, half squared becomes a quarter. And when you divide by a quarter, this answer increases 4 times the original. That could be also an answer, halving the mass, right? Or halving the smaller mass, right? If you halve the mass, if you halve the mass, you will have the force. Here I'm talking about the radius. If you have the radius or the distance between, then that will go 4 times. Doubling the distance between the masses, if you double the denominator here, that answer will decrease. So that's out. So C is out. Halving the smaller mass is also out. Half the distance between their masses, I think that is the answer. Because F is inversely proportional to the distance between their centers squared. If I halve this, if I replace that with half, half squared is a quarter. And when you divide by quarter in maths, the answer becomes 4 times the original. So this is the best option, D. So remember that, ladies and gentlemen, when you're, and it makes a lot of sense. Halving the distance means bring this object closer. And if they get closer, the force must get stronger. It's common sense. Must. Right? Next. 1.7, multiple choice again. This was a question that I did not pick from any exam paper, but rather I designed myself. And it catches a lot of people unaware. An object of mass m projected vertically upwards from the top of a building. At its maximum height, it has 0 acceleration. Now, when you project something at maximum height, there's your maximum height. Your final velocity is 0. Your initial velocity is going to be a maximum, like 8 ms, 12 ms, and it starts decreasing with height until it reaches 0 momentarily, and then turns and comes back to the ground with a final velocity that we don't know at the moment. Right? But if you take that sector, that V final for that section is 0. Which of these 4 options is the best option to describe the position of the ball at maximum height? 0 acceleration, a downward velocity, a constant force acting on it, or an average acceleration of negative 9.8 vertically downwards. Does it have 0 acceleration? No, it doesn't. The earth is pulling it constantly. Does it have a downward velocity? No, it doesn't. Its velocity at maximum height is 0. Now it's between C and D. The answer is C. You cannot describe a negative vector with words in English. If those words were missing, D is correct. You cannot describe a vector with a minus sign in English. This must be plus, and then that English is correct. You only use negative 9.8 in a calculation. D is not a calculation, it's a statement. Do you understand? So that is what trapped many learners and wrote option D. A constant force is acting on it is correct. If I draw a free body diagram at maximum height, there's only one force. It's called weight. So it was a trick in English, had nothing to do with physics. Okay, the answer is C. 2.1. Two masses, blocks A and B, 2 and 5 kgs are connected by a string. The blocks, you guys in front, I don't think you'll have this question. You can take it down quickly. Draw the blocks, draw the 5 kg, the 2 kg, and the angle at 20. The frictional forces are 10 and 15 newtons respectively. Respectively means in order. 10 and 15 in order. So we know kinetic friction is backwards on the small block. I'll call that FK1. And there's a kinetic friction FK2. Please label them different kinetic frictions because they are on different blocks. Do not call them FK or F. F1 and F2 accepted. Right? And this is also against the direction of motion. Okay? So far, the forces that we've got are kinetic friction. There's obviously a tension in that cable joining the two blocks. And this is the applied force, which is unknown. Okay? Because they say unknown F. The force makes an angle of 20 degrees to the horizontal. The horizontal is the parallel line to the ground. State Newton's second law of motion in words. Again, you can write it as F net equal ma in English. When a net force acts on an object, the object accelerates in the direction of the net force. This force is directly proportional to the acceleration, but inversely proportional to the mass of that object. Or you can write it in terms of momentum. The rate of change of momentum is directly proportional to the net force and acts in the direction of the net force. Right? Both options will be marked right. Draw a labeled free body diagram for all forces acting on the 5 kg block. Now again, we are taught by our educators that you pretend the other block wasn't there. So you get off, right? Hide that block. Right, what do you see? You see a cable pulling up. You see a cable pulling backwards. Right? What you can't see, what you drew on your question paper, is the kinetic friction also backwards. So those are 1, 2, 3 vectors. And the invisible vector, the earth pulling down, is called weight. And the normal force is counteracting this, or the surface pushing up. That's your 5th mark. So what I have done, vector diagram. Now if you draw a vector diagram, you're going to get 0 because the examiner said free body diagram. So I'll show you the marking guide, my handwriting. Right? That is your free body diagram. Okay? Now you'll notice I also put in the dotted lines Fy and Fx, but notice they've got no arrows. So please do not put arrows on them. Well, -1 for me. But mine looks 90 degrees in the picture. It's not drunk like some people's arrows. But anyway, so if you look at the 5 ticks, the 5 allocated marks are for 5 solid arrows. Do not put dotted lines for arrows at all. Do not put arrows on dotted lines at all. If you want to show the component, you can actually write this as F cos theta. That's not a force. You are telling the examiner that there are components in this question which I will later use. This Fy is the force sine theta. And if you're clever enough, you can say theta is 20 degrees. It was given. You can see theta is equal to 20 degrees. So you know the only missing part there is F. Yes? Sorry, the tension. Yeah, what about it? Yes, yes, yes. Tension T. But I did write it in my question paper, right? Tension T. So when we coming to these kinds of things, please, we have to be very careful. Now, you may wonder why that I put the dotted lines. Remember, this entire box or system is moving sideways with a F net to the right. Now, if something is moving sideways, you can only add vectors that are parallel to that direction. Unfortunately, F is at an angle. We cannot add that force to tension and Fk. But what we can add to get our equation later is F cos theta to Fk and tension, because they are collinear. You cannot add non-collinear vectors when you are calculating F net. Please remember that. So that is the reason why I put the dotted line, to tell the examiner that when I'm going to start my additions, I'm going to add the dotted line to these two to get my F net for this box. I'm going to add that dotted line to the normal and equate it to the weight, because these are the two vectors that are linear to the weight. You can't exclude that dotted line, because that dotted line there, the Fy, is telling us that the normal is not absolutely equal to the weight. The normal is the weight minus Fy in this case. So that is the reason why I did it, to remind myself that there are two vertical vectors balancing one vertical, one below it. There is a dotted vector called Fx on the right that is added to these two on the left. And these vectors will cancel vectorially when you add them, right? Because up can be positive, down can be negative. They'll cancel vectorially. You'll see that later on, right? So the next question, 2.1 point. Now we need to calculate the force F that must be applied to the 20-degree angle to make the blocks accelerate positively at 2 ms squared to the right. Now, you cannot do that calculation if you have only one free body diagram. It's a trick that the examiner is doing now. You've got to have both free body diagrams and equate them simultaneously. Now, if you look at the second block, I'll draw it in rough here quickly. This block will also go forward with its own F net. But there's only two horizontal vectors. You only include the horizontal vectors when you are sliding the blocks forward and backward. You exclude the vertical vectors in your F net equation, because this is the most challenging thing for learners. F net is always the sum of all vectors. So we're going to add those two vectors vectorially. Obviously, I'm going to put a minus sign there because it's backwards. So I'm going to say for the first block, right? Let me just quickly draw the free body diagram. Tension T versus Fk1. And we know it is moving to the right. We know it is moving to the right. So this will be the bigger vector. That's why it's moving to the right. The big one pulls the small vector. So T minus Fk1 is equal to F net, which is equal to Ma. And now you substitute T minus Fk1, which was 10 newtons, is equal to M. The M was 2 kgs and the acceleration was also 2. And you'll find I've only got one unknown. I can solve for T. T is equal to 4 plus 10, which is 14 newtons. So the first block helped me calculate the tension. Now I look at the second block. I'm only drawing the horizontal vectors, the Fx, the Fk2, and also the tension T. And this block was also being accelerated forward to the right. So Fx will be the biggest vector. And I teach my learners always, F net is always big minus the small ones. big minus small. So F, the big one is Fx, which is F cos theta, minus the smaller ones. Minus the smaller one is equal to F net, but the data sheet said F net is equal to MA. And the rest is now maths. Substitute everything. F cos of 20 minus the kinetic friction of block 2 was 15 minus the tension, which I just worked out. Hello, it's 14, is equal to M, which is the big block 5 times 2, which is 10. And you can solve for F to get an answer of 41.5 newtons. Please note, when it comes out comma 5, please put the 0, because the examiner's instruction is round off to a minimum of 2 decimal places. If you left out that 0, it becomes 1 decimal. You disobeyed the instruction, it is marked wrong. Okay? And that is your answer for F, for 5 marks. Okay? So, whenever you are given a system of blocks, although the examiner asks for one free body diagram, make sure you draw the free body diagram for both, because you can clearly see the free body diagram that wasn't asked helped us calculate tension. And then this tension helped us calculate F. Otherwise, you would have had 2 unknowns. F and T were missing, you can't solve it. Okay? Right? The marking guide, okay, this is my personal guide. This is how I marked this question. Right? You must be very clear, it's only 5 marks. So 1 mark for data sheet. 1 mark for the complete equation, so any mistake wrong. 1 mark for the complete left-hand side correct. Now 29 means I added the 15 and 14 to get 29. There it is here, those 2. 1 mark for the complete value of 10, 5 times 2. And the last 5th mark is obviously the answer. Right? If you gave it in 3 decimals, I also marked it right. Okay? And that is the way to go for mechanics or Newton's laws. Now we go to Newton's gravitational law, which again was quite neglected in the past. I hope it's not neglected for you guys. Right? You've got the planet Earth with an orbiting satellite. From the center of Earth to the center of the satellite is what we can calculate. We cannot calculate anything else because the gravitational law states clearly that every mass of satellite, mass of Earth, every particle in the universe attracts every other particle with a force F, which is directly proportional to the product of the masses and inversely proportional to the square distance between their centers. We think of each of them as a dot, a tiny dot, and that's the R squared or D squared you can calculate. Nothing else. You cannot calculate this. The examiner was clear. The examiner wants this distance between the Earth's surface and the orbit. Calculate the distance above the surface to the orbit where the satellite is. So you are going to calculate the distance from center to center. How we get to this is a mystery. So let's do what we know. Let's do what we know. F is equal to G, M satellite, M Earth, all over R squared. And F is given as 1842,50. G is 63. 67, no, 63 is blank. Times 10 to the minus 11, multiplied by the satellite's mass is 200, multiplied by Earth's mass, which learners were calculating, but it's in the data sheet, 5.98 exponent 24, all divided by d squared. And you cross multiply and solve for d after square rooting to get an answer which is quite big, 6,58 exponent 6 meters. So d, the distance from center to center, remember d is center to center, surface, center to center, not surface to surface, right, is that value, 6.58 million meters. How do I get that small distance there? When I'm given the whole distance of that arrow of 6.58 million, do I know this distance that I've bracketed here, the radius of the earth? Yes, it's in the data sheet. So if I subtract this from that radius, I should get the balance left over. So height is equal to 6.58 times 10 to the 6. Subtract the radius of the earth. Do you know it? Where do you find the radius of the earth on planet Earth? In your data sheet. What is the radius of the earth? It is 6.38 exponent 6. And you get 0,2 exponent 6 meters or 200,000 meters above the earth. Right? That is your answer. So for a 5-mark question, if you stopped here, you get 3/5. If you subtracted from the radius of the earth correctly with the answer, you'll get the 2 more. So be wary of this. When the examiner puts bold print, capital letters or underlines it, it means there's some tweak in that question. Okay? Are we all clear with that question? Good. And that is Newton's laws finished for the day. Now we look at our next favorite chapter, VPM, or vertical projectile motion. Now this question is from a past paper that has been tweaked. This is a 2-dimensional question, meaning there's 2 balls at motion here. A ball X is thrown vertically downwards with an initial speed of, immediately you're going to do this, down is negative. Immediately you're going to put this minus sign there because it is downwards, ball X from point P. At the same instant, an identical ball Y is dropped from a point Q 4.9 meters below P. So this was dropped. So VI here is 0. A is minus 9.8. Here VI here is negative 2.5. A is minus 9.8. And you can see, ladies and gentlemen, you are stuck for both, because we as teachers teach you, when there are 3 known values, you can pick any formula in the data sheet and you solve it. You've got no other values for both sides. So this becomes a level 3 plus calculation. And unfortunately, in that year, I was quite an evil person. I set it for 19 marks. So if you got it wrong, you lost 19 marks. Okay? So what can we do to beat the examiner? Everything. That distance it fell is missing. Am I right? No, it's not. Call that displacement x. Now you got a value. It's called x. But it will be minus x. Why? Down is negative. It's falling down here, isn't it? Now, if that distance was x, what will the distance fallen by ball Q or ball Y be? X as well. Or x minus that balance. So it will be delta x for this ball is x minus 4.9. But because it's also falling down, put a minus sign there. Now how many values you got for both balls? Now you got 3. Problem is solved. What will be common for both balls? Let's see. Underneath the diagram, this teacher's nasty. He said both balls hit the ground at the same time. So we can call the time for both balls T. The time taken for the journeys for both balls will be T. So instead of having 2 unknowns or 2 values, I have 4. Who said the problem is difficult? It's not difficult. If we think, we can ink. Remember that. If you think, you can ink. Don't give up when you saw 1, 2, 3, 4. I made it now 8 known values. And now you can get 100% full marks. Let's see how we start. It's unfortunate that the examiner also insisted you choose down is negative. Now, if they say down is positive in the national paper at the end of the year, you do this, down is negative. You do your whole question as down negative. I know you broke the examiner's law. You didn't follow him. But you do it as down negative, and you will get all right still. But at the end here, the examiner will put -1 because you took down as negative and give you 18 out of 19. Are you happy losing that 1 mark? If you want to gain that mark, then you go and follow him and say down is positive. If you mess up the signs here, you get 1 out of 19 instead of 19 out of 19. So I tell my learners to keep down negative in all exams you write and forfeit that mark. You rather lose that mark and get 18 than try and be too clever and go and get 19 when instead you'll get 1 or not. Because your sign convention is very, very dangerous in this question. If you didn't put the minus sign there or there, you are gone. You lost all our marks. Because I chose down negative. In this case, you had to choose down negative, by the way. Once the balls are in motion, they're said to be in free fall. Give a reason to support the statement. The only force acting on each object is the gravitational force. Please don't write FG. You write gravitational force in English. Right? What's the difference between projectile motion and this definition? Projectile motion is the object initially is given a velocity and then released, where the only force acting on it is the gravitational force. That's the difference. An object is given an initial VI, or the VI for that object is non-zero in flight. Right? Next, 3.2, let the time travel for both balls equal to t, and hence calculate the time taken for ball y or x, because the time is the same, to hit the ground. Now, that comes from here, ladies and gentlemen. I'll do it in a different color. There is only one equation for these balls, A, X and Y, or A and P and Q. It is delta X VI delta T plus half A delta T squared. No other equation will work here. Nothing else. So you're going to use this equation twice. Delta X here is minus X. VI is minus 2.5 T plus half of minus 4.9 T squared. And you can simplify that as minus X is equal to minus 2.5 T. Positive times negative is negative. Not 4.9. I did it in my head already. Half of 9.8 is 4.9 T squared. Can we do anything with it? No. Draw a box and call that equation 1. And now we do the same thing on the other side. Use the same equation above. Delta x equals VIT plus half AT squared, right? And here we'll put minus into x minus 4.9 for delta x. 0 is VI, 0 times t is 0, plus half of minus 9.8 t squared, which is minus x plus 4.9 is equal to minus 4.9 t squared. And now we can do something with this equation. Take the 4.9 that side. Minus x is equal to minus 4.9 t squared minus 4.9. And call that equation 2. Now if you notice, what is that? Negative x. What is this? So isn't that side will equal to that side? So the x's fell away now, isn't it? And you can solve for t. So you'll say equation 1 is equal to 2. And when you equate the two, you get delta t. Please put the triangle back. I dropped it off here. You can put it back in the end. 1.96 seconds. Right? Equation 1 is equal to 2. You equate the two and you get delta t to be 1.96 seconds. If you want to see it neatly, you want to see it neater than this, then I have it in my memo. Okay. Right, there's ball X, there's ball Y. Right, you substitute it and you get 2.5 t is equal to 4.9 and t is 1.96 seconds. Okay? Now that you've got that time of 1.96 seconds, the entire problem is now unlocked. You can solve for any given value. Okay? 3.3, calculate the velocity with which ball X strikes the ground. So if we go back to ball X is this one. Okay? So we want the V final for ball X. So we've got VI, we've got A, we've got VF missing, but we also now got the time to be 1.96 seconds. So I think that for number 3.3 is self-explanatory. 3.3, VF is equal to VI plus A delta T, which is minus 2.5 plus minus 9.8 multiplied by 1,96. And you will get a negative velocity, which is absolutely correct. Negative 21,708 meters per second. Now let's go back to the examiner. The examiner asked velocity. The examiner asked velocity. So that must be a positive number with a direction. So this is not the answer. That is 21,71 meters per second rounded up. Downwards is the answer. So it's 3 marks, equation, substitution, answer is this. There is no mark for that negative value. So please be wary of the word velocity versus the word magnitude of velocity. If I said magnitude, then we'll tick that. If I say velocity, we don't tick this. You leave it like this, we want to put a cross there and give you 2 out of 3. Right? So please, be wary of the English. It can trap you in your physics. 3.4, calculate the height of point Q above the ground using information from ball X or Y. So they need the height Q of ball Q, this height here. Now if you solve for X, It'll be x minus 4.9 and you get the answer. So, let me just show you my memo again. 3.4. Right? I chose that equation. You could have chosen any of the equations of motion now because you do have time. Delta x equals VIT plus half AT squared, and I'm solving for delta x. Okay? This was in my previous equation for ball x. Okay? Ball y, sorry, half of that, and you get your answer of 23. X is 23. If you go back to the question, this entire height is x, but the examiner wants the height for ball y. So you subtract 4.9, and that's what I did. Okay? At the end. Okay, that's your height. Okay? 18.82. You got to subtract it. Right? Notice the mark scheme again. 2 marks for solving for x. The other 2 marks are for subtracting the 4.9 and the answer. So again, watch the English. Watch the English. Okay? Next question. Next question. Will ball y strike the ground with less than, greater than, or equal to the velocity of x? Now let's go back here. Right? Ball x was thrown with an initial speed of 2.5. Then it hits the floor. Ball y was dropped. So which ball will hit with greater speed at the bottom? X or y? X or y? Really, why? This thing fell 4.9 less and it was dropped from rest. It had no velocity. This ball was flung down. It was thrown down. Agreed? So it will be definitely the first ball. Okay? So let's answer the question. Will ball y strike the ground with lesser, greater? Ball y is the second ball. Less than. Less than. 3.6 is our favorite question. On the same set of axes, you know this is coming, people. Sketch the velocity time graphs for both balls. We are to draw the VT graph for both balls. Indicate the relevant V velocity values and label your graphs. They are telling you again, label. If you don't label the graph, you are getting 0. If you don't label the graph, in this case, the child had 2 options. You either label it P and Q or X and Y, because P is X and Q is Y. So they had 2 options. But here I'll say X and Y. So, velocity time graphs, ladies and gentlemen, can never be curves. They are always straight lines rising or straight lines falling. There will never be curves with vertical motion. Never. Unless it's a level 4 question. Then we don't worry about that one for now. Right, so VT graph, down is negative. So 3.6, we know VI was minus 2.5 for ball X. Right? We know VI was minus 2.5. We know the final time was 1,96. Now whatever error you made in your paper, if your final time was 10 seconds and you put 10 here, you will still get full marks for your graph if you carry over your wrong time with the right shapes. Your shape can't be wrong, your time can't be wrong. Then you get naught. Right? And for ball Y, VI was 0 and VF is less than, VFY was less than VFX. So how do we draw this with down being negative? Notice what I've done. I've drawn the negative y-axis longer than the positive y. Can you see that? Because my velocities are negative here. There's it, negative. And my V final was negative 21.1 or something it was. 21,71 for ball X. V final was negative 21,7. So negative numbers can't go on the positive Y. You see, your calculation makes you draw your graph. You can't draw a graph like this in this case. You've got no positive V values. You can't draw that. So, let's draw the first one. -1, -2, -2.5 will be somewhere here. -3 is there. -2. There's -2.5. So this graph will start there, straight line, and it will finish at a negative velocity of negative 21.71 meters per second. So that's for ball X. Now, ball Y starts with a velocity of 0. And the finishing time for ball X, let me get it right. From the x-axis, the time axis, time in seconds. From the x-axis, the finishing time was 1.96 seconds. So, ball Y is now starting from rest, 0, the origin. 0, 0, so it starts here. And it finishes less than the speed with ball X. Correct, this is less than that. And also finishes there. If you extended it, see if you extended it beyond 1.96, marked wrong. Because the ball's finished at the same time. It mustn't be there. And these two lines have to be, they have equal gradients of negative 9.8. The gradient of this graph is the acceleration, 9.8. It's negative 9.8. Parallel lines, parallel graphs have equal gradients. You should know that from maths. Okay? And that's your VT graph, ladies and gentlemen, for these two balls that were dropped from these two heights. I hope this one comes out in your paper, same one. At least you're going to get 19 marks. Okay, now let's move on to, yes? Sorry people, I need to hear this gentleman. Yeah. Okay, let's look at my original purple writing, my given information. This is what you were given, right? There was no velocities given for either ball. The only thing you know is that the time is constant for both. So even if you put time is t here and time is t here, if you chose a velocity equation, you're going to have more unknowns than before. The only way to go through this question is try your velocity equation and see. You'll never solve this thing simultaneously. The only route to go is the displacement route, where you can see this 4.9 meter drop here will give you a hint that the displacements can be linked together. If I call this one x and this will be x minus 4.9. That's the only way I can do it. The velocity thing did cross my mind. I tried it too. And it failed because VFs were not given for both balls. So I struck it off and looked at delta x's. And whenever you come with these two-dimensional problems, the way to go, 99 out of 100 times, this equation is going to be your best friend. Delta x equals VIT plus half AD squared. If it doesn't work, then it will be another equation on the data sheet. But 99 out of 100 times, this thing works. I'm telling you. Okay, it's a good question, my boy. Thank you for that. Okay? Because the unlocking of the mystery of this question was here in purple. Once you got this purple writing correct, the rest was maths. Let's be honest, it's maths. There's the physics here. The physics is this. These simultaneous equations is what you did with your maths department. That I got no time for. That is your baby. But this is what we teach, science. Okay. Our next question is a question 4 based on momentum. People underestimate the value of momentum and impulse. Please do not, because you will regret it severely at the wrong time of your life. Right? A cannon has a mass of 1,250 kgs and is 1,000 times heavier than the cannonball. So immediately I'm going to say the mass of the ball is 1,250 divided by 1,000, which is 1.25 kgs. Because this is, when you multiply this by 1,000, I'll go back to that, correct? Okay? So I know the mass of the ball and the mass of the cannon during a routine training exercise. The ball left the cannonball at a velocity of 80 ms. So I'm going to say to the right is positive, plus 80 ms. So before firing of the ball, where was the ball? It was inside the cannon. So before firing and after firing. Before firing, after firing is our momentum law. We don't say before collision, after collision. The total linear momentum before a happening is always equal to the total linear momentum after the happening. And the happening here was firing of the cannon. Before firing, the total momentum is conserved. After firing, the total linear momentum is also conserved. That's how I do it. Okay? So, before firing, what was the motion of the ball and the cannon? Moving or stationary? So, it had 0 kg ms momentum. After firing, it should have a total of 0 kg ms as well. The examiners employ this trick. They also write information underneath the diagram. Don't forget this. The cannon comes to rest in 1 second. This is important for later information. Define the word impulse. Impulse is the product. Let's look at the mathematics. F net delta T is equal to delta P. There is impulse. Impulse is the product of the net force acting on an object in a certain time interval. Take it from here, which came out in your trial and you all got it wrong. You all wrote change in momentum. It was marked wrong. There's the definition here. Convert this into English. It's in the CAPS document. Right? If you want to see the definition in words, here it is. Impulse is defined as the product of the F net and the time interval for which that F net acts. That is the definition. No other answer. No other answer. Don't try and get too clever. You are not the guideline document, learners. We are. Next, calculate the maximum velocity with which the cannon moves backwards. Now this can take the root of the law of conservation of linear momentum, or it could be using this law. Now this is Newton's second law. F net is equal to the rate of change of momentum. You can solve this maximum velocity using that or that, provided they give you information on F net, isn't it? But in this case, that is missing, only time was given 1 second here. So you can't use that law. You got to use your own law from your brains, which is this. The sum of the initial momentum is equal to the sum of the final. Mass of cannon plus ball with an initial VI is equal to mass of cannon, final velocity of cannon, plus mass of ball, final velocity of ball after firing. Mass of cannon was 1,250. Don't forget, the ball was stuck inside. So add the ball mass of 1,25 But they all were starting from rest. So that's its initial velocity. After the firing, the cannon's mass is still 1250 with a funny velocity unknown, final velocity. But the forward velocity of the ball was plus 80. And the rest is maths. And if the examiner said the cannon went backward, your answer should come out negative. Correct, it did. But that is not the answer. He said, write the velocity. This is not a velocity, learners. This is a magnitude of velocity. Please understand the difference. A velocity will have a value with direction. Please look for the word magnitude. If the word magnitude, you stop there with the unit. kg/ms. I didn't even bother putting the unit because I knew that answer is wrong. The answer is velocity. A positive answer always with English. Then you'll get the tick. Please don't sell your marks short. Right? 4 out of 5 is not a nice mark to get. You could have got 5. You were careless. Right? I hope online you are becoming clear with that. Yes, boy. That was in your exam paper. You got to work out the period, the time taken for one ball. You got to use the wave equation, unfortunately. Period. F is equal to 1 over T and T is equal to 1 over F. Right? I'll show you that in class when I get back. Right, next. 4.2.2. They want you to calculate the net force causing the cannon to come to rest. Now, this answer, I like to do it with you because there are many ways of doing it. Many ways. Right? There are about 7 options to do this thing. Right? F net is equal to delta P all over delta T. But remember, learners, we had a mass of the cannon and the mass of the ball. VI cannon, VI ball, VF cannon, VF ball as well. So we've got a lot of values for M and V, and this is where the problem arises for learners, because we can't use these equations or this equation with delta P unfactorized. We've got to find F net as first factorizing delta P as MVF minus MVI all over delta T. And the examiner gave us 1 second to stop. Now the mass, velocity and velocity, look at this. 1, 2, 3, 4. VI for cannon, VI for ball. Which VI will fit here? Do we add those VIs? Do we pick one of them? Do we leave out another completely? What M and what V do I choose is my question. Do I take the cannon? Do I take the ball? Do I take the sum of them? Or who cares? Take anything. The answer is who cares? You take either one of them, you get the same answer. Must I prove it? So I'm choosing the cannon. So I'm putting C, C, C. Right? Mass of cannon was 1,250. V final of cannon was negative 008 backwards. Remember, initially what was the cannon and the ball doing? Rest, minus 0. Right. And when you divide this and subtract it, you will get negative 100 newtons. That is 100 newtons backwards. The examiner said use the word backwards. Okay? Now, let's take which mass I ignored so far. Mass of the ball. Let's take the ball. Right? I'll do it here. Equal to Mass of ball was 1.25. What was the final speed of the ball? 80 plus 80, isn't it? Initial speed of the ball was 0, and the time taken to stop was 1 second for the cannon. I'll bet you'll get 100 newtons, but you get a positive answer. Because Newton's third law comes into play here, ladies and gentlemen. Cannon pushes ball forward. Force of cannon on ball. Reverse these two nouns. Force of ball on cannon. Isn't both of them will be equal but in opposite directions? They have proved it. There's your answer, minus 100 and plus 100. So it doesn't matter. But what you can't do is this. This is madness. Take the value for the velocity of the ball and go put it inside here now. This is cannon, cannon, cannon. Please make it clear that you have like terms. This is what you guys were doing. You were putting information unnecessarily from the right on the left, or taking answers from the left and putting on the right, and getting a whole sort of mixture of answers. To check your work, there's a check. Use the cannon, get your answer. Use the ball. Answer should be the same or opposite directions. Then you are right. I hope I made it clear, ladies and gentlemen. Right, good. Let's move on. Time is of the essence. Okay. Question 5. Now, we haven't touched on this in a long time, or me, I haven't touched on this in a long time with you guys, online or not. This is grade 10 work. Let's not kid ourselves, ladies and gentlemen. This is the law of conservation of mechanical energy. U plus K initially is equal to U plus K finally. Or some teachers say EP plus EK is equal to EP plus EK. Or they use the word bottom and top of journey. I don't care what words you use in English, but I want to see the sum of the energies before the incident and after the incident being equal to each other. That's what I want. Where this pendulum swings is irrelevant. It will always have 4 single energies. U, K initially, U and K finally. Get it through your head. This equation doesn't change in the journey. Even if this value is 0, 0 for U or 0 for kinetic energy. 0 is a value. Let's not kid ourselves. So substitute them. There are 4 energies in the EMAC equation. That's what this means. Mechanical energy initially is equal to EMAC finally in a system. Right? And what's common is the masses in the system. The masses in the system are not changing. Remember here, there's no ball. The ball is still here, about to hit this pendulum. Then the ball got stuck in it. So you got to add the ball mass to the pendulum mass, or the clay mass to the ball mass. Please remember that. Many learners forget to add the small piece to that big piece. And that will mess you up and you will lose a lot of marks. The other places people lose marks, which is embarrassing. You don't convert this to kgs. Again, the moment you see gram times 10 to the minus 3, which is 0,057 kgs. This is 500 grams. That is 0,5 kg. Straight away change it while you are reading. Straight away change it. Divide it by 1,000 and change it. And make sure that every unit on the left-hand side of the equation and the right-hand side for mass is kg. Otherwise, again, you're losing 11 marks. It is very important. Here you got lucky. The maximum height is given in meters. Trust me, at the end of the year, they're going to give you centimeters. Or they're going to give you millimeters. Divide by 100 to get in meters. Divide by 1,000 to get in meters. Yeah. Please. These things are no-brainers. You get all this wrong, you lost all the marks. Forget the equation. You don't know primary school maths. This is primary school maths, people. This is unacceptable for 18-year-olds to get this wrong. Unacceptable. Okay? Remember, the marker is not your friend. We are not there to help you. We are there to do our job. Must understand that. Right? So, what happens here is this ball clutters, this clay clutters into this ball, which was at rest. Then they take off with maximum speed, slow down, slow down, slow down, slow down, and stop at maximum height. And now we want answers for this. What answers do we want? Firstly, we want English answer. State the law of conservation of mechanical energy in a closed system or isolated system. In an isolated system, no more closed, the total mechanical energy remains constant. Straight from the data sheet, the CAPS data sheet, the CAPS document, or is always conserved. No abbreviations like me. You write all in full English. Right? Number 2, calculate the magnitude. I love that word. Magnitude means no direction. We don't need it. Calculate the velocity of the ball and clay after they collide. Now, I'm sure you, ladies and gentlemen, have done with your teachers combination questions where the teacher combined the law of conservation of momentum with the law of conservation of energy in one question. Have you done that? Now, the question is, for 5.2, which law do you choose? Momentum or conservation of energy? Let me ask you this question. Which law did you define up there in number 1? Energy, isn't it? So the examiner is telling you a clue. Use the energy law here in number 2. Right? And I will do it. Right? I will do it. Right. U plus K at the bottom. I know many of you don't like that word initial and final. U plus K at the top. Now some of you are very lazy. You all don't like this. MGH at the bottom plus half MV squared at the bottom is equal to MGH at the top plus half MV squared at the top. You all are lazy to write this. I don't know why. This is how you solve the question. So the mass of this, now be careful, be careful. Let's go back here. When this pendulum swings, is this ball empty or combined with the clay? When this ball swings to that height, is it swinging alone or combined? Come on, it's obvious. It's combined. So please add the mass of the ball to the clay and you get 0,557 times 9.8 times 0. I'll tell you why 0. At the bottom, do you have any height to climb yet? No, that's why you put 0. Plus half of 0,557 times v squared. Do I know the takeoff speed here, or am I asked to calculate the takeoff speed? Let's see. Calculate the speed or velocity after they collide. So I'm asked that speed. So v squared. MGH at the top will be 0,557 times 9.8 times 1.04. Now see what I'm writing in the end here. Why did I say the kinetic energy at the top is 0? Because of this word here. When the object reaches maximum height, its final velocity is always 0. We did that in vertical motion, remember? When the maximum height is reached, V final is 0. So if this is 0, 0 squared times 0 times half gives you, got it? And you get V at the bottom to be, oh, I don't know where my memo disappeared now. It's quite a high value, 40 something. 40, oh, there it is here. The final answer is, oh no, sorry, not 40, sorry. The next answer is 40. Right, 4.52. Oh, this was a very nice one. Let me write it again. If you find the square root of that entire thing, you get an answer of 4,515 meters per second. Now this is a nasty examiner. If you round it to 2 decimals, what will this answer become? 4.51? 4.52. Now how many of you will leave it as 1 in the exam? All of you. Because you are rushing for time. Say yes. I hope not. Be careful. This is a nasty thing to do to a child. If you drop that 5 off, I marked that wrong. Now this was only 4 marks. Equation, left-hand side, right-hand side correct. Final answer, that or I accept that. Right? Understood? Now I want to show you, those of you who did it the data sheet way, who understand this way, then those of you who do, in the majority of you in this audience right now, I'm talking about both audiences, I hope, the majority of you that I'm looking at now, did you all do it this way, the grade 10 method? Yes or no? How many of you did it the grade 12 way like this? Using WNC from the data sheet? Not allowed to. Since when? If it's in the data sheet, it's allowed. There it is. If you're doing this method, I hope you understand it. I'm not going to teach it now to you guys. If you did the grade 10 way, you still get full marks. But with this method, what's nice about it, you copy the data sheet equation. This is delta U plus delta K. And the next line you write 0 here, the work done by non-conservative forces. You got 2 out of 5 without writing anything. You can write all nonsense here. You got 2 out of 5. This method here, this equation is coming from your head. Am I right? This is from you. Step 1 and step 2. You make one mistake in either step, you get naught. You know that, huh? You make one mistake, you get 0. These substitutions are based on your equation, not the data sheet. So if your equation is wrong, you're not going to get these ticks. But this kid is going to get 2 out of 5, which is 40%. Remember that. So if you don't know this method, when you go back to school, tell your teachers to teach you this alternate way, please. Right? If I had the time, I'll do it. I don't. Right? Number 3, 5.3. Okay. Use the principle of linear momentum to calculate the speed of the tennis ball before it collides with the clay. Now we need to go back to this. There's our story. Momentum before hit is equal to total momentum after hit. No collision. Okay, we can use collision in this case. They collide. Momentum before collision, that's M clay and M ball. You've got 2 masses. That's before. After, you'll have the same 2. Remember that. You can't lose mass in a closed system or isolated system. Then you've lost the plot in physical science. You can't lose it. So if you started with 2 masses, you'll end with 2 masses with momentum as well. Even if the momentum is 0, it is a value. Let's go on. Okay? Since we're rushing for time, I'll just show you my memo because I need to go and do some electricity with you guys, static electricity. Okay? 5.3. There's the equation. M M clay VI clay, M ball VI ball plus M clay VI clay is equal to M total times V final, because they all combined. That's why total mass. 0,057 is for the ball, right? Let me just put the word B there. Initial speed of the ball was not known. We threw the ball, we don't know what speed. 0, the hanging pendulum had no velocity, it was at rest. After the hit, they combined with 0,557 mass total with a V final carried over from down here. That was their final speed when they took off to swing, correct. And you get an answer of 44.07 meters per second. You can take it down quickly if you prefer. Right? So, again, watch the mark scheme. It's 5 marks. You notice that this was ticked. Generally, the mass is not ticked. In this case, the mass is ticked because you have to understand that the collision was coupled. You have to add those masses to get that mass. Okay? So, and whatever wrong answer you wrote there, if you carried it with all this correct, you get 5 out of 5. Provided you put units. A lot of you are leaving out the units. A physical science paper 1 and 2, if it's got no units, you are wasting your time. You wasted 6 hours of your life writing the final exam. If you keep leaving out units in the final step, I will never do it. Never. Why are you? Your teachers will never leave out the unit. Why are you? You practiced bad habits and now you can't undo it because you're under stress. Please stop this habit. Right? It is not nice to mark this wrong if MS was missing to get 4 out of 5. Physics is a very nasty technical subject. You should have realized this in grade 10. There is no favors for anybody. Right, questions 5.4. I found this question very nice. In a scrapyard, a crane with an electromagnet lifts up a car of 1,000 kgs from rest. So VI was 0 here. X meters above the ground, right? When the car is X meters above the ground, the net work, so this is W net, is 250 joules. And it gains 50,000 joules of potential energy. So when it gains energy, we call that delta U or delta EP. It gained 50,000 joules. Makes sense. If something is on the ground, there's no height to fall. It's got 0 joules of energy, potentially. When it rises X meters, it gains that height as mgx. Its potential energy becomes mg times the height it gained, which is x. Makes sense? So it gained 50,000 joules. From 0 joules, it gained 50,000 joules. So delta E is final EP minus EP initial, which is 50,000 minus 0, which is 50,000. That's what this means when you read the word gains. It means 50,000 minus 0. Okay? State the work energy theorem in words. I'm tired of this question. You go and do it on your own. W net equals delta K. Go and put this in words. Remember, this word means change in kinetic energy. Calculate the height of X in meters. Now, I want to show you how you do this. 5.4.2. Delta U is equal to mgh, which is 1,000 kgs times 9.8 times X is equal to 50,000. Right? That is how you do it. Not you. What you putting? What you putting in the front there? Delta, not EP either. Because the teacher said gain, you're working out the change. Okay? So if you didn't put a triangle, you lost a mark. And you get x to be 5.10 meters, I think, which is the height. Okay? Now, I marked it leniently when I set this question, right? I did not, when the child left the triangles out, I marked it right, right? But I took out one in the first step only. If you've got negative values, you can't have negative height in life. You can't say I'm minus 10 meters tall. Doesn't make sense. We don't accept it. Okay? 5.4.3. Use energy principles to calculate the velocity of the car at x meters for 5 marks. Now, we need velocity. VI is 0, VF is question mark. Mass of car is 1,000. Which W net equation is applicable, you think, from the 4 equations I did yesterday? It has to be the one with M and VF and VI, isn't it? Which is the work energy theorem. So 5.4.3, W net is equal to, stop writing delta K, start straight away. Half MVF squared minus half MVI squared. And I believe they gave us W net. Yes, it is. The net work is 250. There it is. So 250 is equal to half of 1000 VF squared minus 0, because you started from rest. And V final is something. 0.707 meters per second upwards. For 5 marks, 3-line answer. Thank you, examiner. Thank you, examiner, for that. Right? 5 marks. 0.707. Please watch out. Watch out. These are squared velocities. Do not leave the square out. Meters per second upwards. Right? 5.4.4. Right? This question is a very nice question. Right? Because you haven't seen one like this, or have you? Audience? Ever seen one like this? No. So I'm hoping one comes out like this at the end of the online audience. If you did, well and good. If you didn't, then we need to focus. Right. Calculate the work done by the crane to lift the car X meters. So we want the work done by the crane or the work done by tension in that rope, because that rope is connected to the crane. Make sense? Now, you cannot solve this thing just by looking at it. We got to draw a free body diagram for the car. How many vectors are acting on the car? Which one pulls the car down naturally? Which vector pulls it down naturally? Gravitational force. Wait. Which vector is pulling the car upwards? The work or the vector tension, which is coming from the crane. Any other vertical vectors on this car beside those two? Any friction? Let's see. Oh, there's it there. Ignore air resistance. So there's no air friction. There's no mechanical friction. They didn't say anything about friction in the motor itself. So there's no friction. So the only two vectors doing work on this car are these two. So we make up our equation. Remember, W net can't help you. Why? Let me show it to you. These are all known values now. It cannot help you. That's given, that's given, that's given, that's given, that's given. So you can't use W net equals delta K anymore. You got to make your equation from your diagram here. W net is equal to the sum of all work individually, which is the work done by weight and the work done by the crane or tension. But W net is 250. The work done by weight. Now pay attention, learners. Learners, pay attention. You see this here, 50,000 joules of energy gained is actually the work done by W, weight. Did you know that? Delta U. Okay? So if you didn't realize that, now you are going upwards. Car is going upwards. But the weight vector is downwards. So you'll put minus here. Whenever the vector is opposing the direction of displacement, you put the opposite sign, plus work done by tension. Take the minus 50, becomes 50,000, plus 250, which is the work done by tension, which is the work done by the crane. 4 marks. You had nothing to use from the data sheet, because all the values for the work done was given. All you have to do is make up your own equation. This was a trick. This was the trick. The trick was that minus sign. It wasn't given in the data. It was not given here. It was given as a plus here. Right? When you gain potential energy, you had no potential at the start on the ground, but you gained 50,000. But if you have to go back down, isn't you going back in the opposite direction? But you are being displaced which way? Which way the car was going? If weight had to pull you down, weight will pull you down. But the car was going, that's why you put the minus sign. You understand? Because the definition of work is done when a force is applied to an object and the object moves in the direction of the applied force. That's called positive work. Negative work is when the displacement and the force are in opposing directions. It's still work done, but it's negative work. Okay? Many of us don't teach that, but it's in the syllabus, because there it is in the exam. And then 5.4.5 is a joke. Calculate the power. We're assuming 100% efficiency. Power is equal to the total work done by. Now we got a problem. I got W net. I got work done by weight. I got work done by tension. Which work is put on the top here in this equation? Work done, I've got 3 options. Network, work done against gravity, and tension, work done by the cable. I always call it applied work. Which force is the applied work here? The applied force doing the applied work. Net, gravitational, or tension? There. This one. And the answer was 50,250. So 50,250 divided by, is this in minutes? Hey, this is shocking. Learners put divide by 2 here. You're supposed to say seconds, multiply by 60, and you get 418,75 watts. Right? Calculate the power, 417,75. Which, ladies and gentlemen, shockingly gives you a total of 29 marks. Now, I hope they don't give you a 29-mark work, energy, power question. Okay? We've got 15 minutes. Look, the Doppler question. Well, it came up. The Doppler question, I'm not going to go through it now because I need to give you, I'll show you the answer to the Doppler question. I'll just go through it in a few seconds, because I need to do the static electricity with you. The Doppler question A submarine underwater, did I do this yesterday? No. A submarine underwater detects a ship, a moving ship. A submarine is at rest, just below, detects the frequency of the ship as 437 hertz, which is 0,985 times the actual frequency. The actual frequency is called source frequency. Now, this is my question to you. If I want the source frequency, do I take 437 times 0,9 or 437 divide by 0,9? It's not times, it's divide. That was a trick in this question. If you did the opposite, you lost all our marks. You lost 10. The only marks you get is 1 mark for the last answer. Blue shift. So, please, the only mark you get is this 2. State the Doppler effect in words. You'll divide. Now you go and find out why I'm dividing. Why are you multiplying? The frequency of the moving ship is 4,37, which is 0,985 times smaller than the actual frequency. So Fs is bigger than Fl. 0,985, isn't that means it's smaller? Agreed. So the frequency detected is bigger. Sorry, Fl is bigger than Fs here. The frequency detected is 437. This is smaller. You divide it. Right? I'll show you the memo. Watch out for the English. Do not multiply this thing. Be very careful. The other way of doing it is, solve for x. Let frequency of source be x and start like that. And you'll work it out. That's the best way I can tell you. Right? Let frequency of source be x. Right. There's the Doppler answer here. Right? Even first I made the mistake when I did my memo. I multiplied it. Then see what I did after that. I divided. I also made the mistake. We are human. So the apparent change in frequency of sound wave observed by a listener when the sound and listener move relative to each other. It's in the CAPS document. Right? The source frequency is 0,985 divided by 437, which is 443,655 not hertz, meters per second, hertz. Right? The speed of sound in water was given. So is the object moving towards or away? It is definitely moving away because the source frequency is greater than the apparent frequency. As you can see, 443 is greater than 437. Now, if you multiplied, you would have had this answer. And you would have wrote the opposite of this. Please remember. Right? I think there's an error in this paper here. They should have said 0,95 times smaller than the actual frequency. Okay? Calculate the speed of a ship. Now remember, a ship is not a race car. So when you get an answer of around 23, it makes sense. 23 meters per second. Ships do not fly like a speeding Ferrari in water. Okay? And the last answer is not applicable anymore. Blue shift is not examinable in the CAPS syllabus. You need to know what is red shift. Okay? If you don't know how I know it's blue shift, I'll show you the diagram quickly. Okay? I don't know if we'll have time to finish the entire booklet, but see, these spectral diagrams, if you look at a normal spectrum from the sun, this is the gap for red, right? And for blue. We'll only look at the red end and blue end of the spectrum. But if you look now, the spectrum from another galaxy, the red is gone wider and the blue is gone narrower. So you agree this entire lines at the top have shifted that way to squash the blue to make it smaller. Make sense? That's why we called it blue shift. If it was red shift, this red will go to the right and that band will become small here. So we'll say it's red shifted and the universe is expanding. Do you understand? Expect these spectral diagrams to appear in multiple choice, for example, because they've done this in class many times. Right. Question 7. We've got 10 minutes. I want to do this. because static electricity was last revised in grade 11. Two charges Q1 and Q2 are a distance 40 centimeters apart. Divide by 100 immediately. 0,04 centimeters becomes 0,04 meters. Right? The charge on Q1 is 3,8 nanocoulombs. Please stop getting to the idea of teachers expanding nano for you. They're not going to do it anymore. You are now in the final exam. You must know milli, micro, nano, pico, femto, and atto. Right? The electrostatic force between the two is that amount of force. State Coulomb's law, I'll write it in mathematics. All over R squared. Between any point charges at rest in a vacuum, there exists an attractive or repulsive force. This force is directly proportional to the product of the magnitudes of the two charges, but inversely proportional to the squared distance between their centers. It is not negotiable. 4 lines for 2 marks. Calculate the charge on charge 2. This is straightforward. 8.54 times 10 to the minus 7 equals 9 billion coulombs constant. Q1 is there. Do not put the signs. No signs. Don't put minus and plus signs here, ever. No signs. 3 times 10 to the minus 9, 3.8 times Q2 divided by 0,04 squared. Now, ladies and gentlemen, this thing is only 4 marks. If you made a mistake with the distance here, by not converting centimeter, you failed. Remember that now. You will fail. If you can't convert centimeters and millimeters, this equation, this answer becomes 1 out of 4. And you get the answer for Q2, whatever it is. Right? Q2, okay, there's it there. 3,995 times 10 to the minus 9 coulombs. You're going to fail. You see, the tick is there for the entire thing. There's no tick here. The tick is for the formula. So the only thing you're going to get is that 1 mark. That's all. And you can see, if Q is a negative charge, no marks. Don't write signs. This is directly from an examiner's marking guideline. Don't write signs. Right? The two charges now touch and separate. What is the new charge on each? This is grade 10. When they touch, you find the average. You add the two with the signs, now you add them. With the signs you add them and divide by 2. Do you understand? It's only 2 marks for grade 10. Calculate the new charge after touching. That's what was the question. So far, so good. Okay? Next question was, draw the electric field around a positive charge. Now again, no more 3 marks. They're down to 2. Your diagram must look like this. No more, I don't care this is computer generated. You must become a computer. If you draw some weird curved lines and all that, and your lines go inside the middle and squiggle on the outsides, the arrow points in the different directions, you're getting nothing. You are getting no marks. Correct direction, field lines not crossing, correct? And also, it must look like an electric field, the shape. It can't look like an ashtray. So they took this mark away now for shape. So if it don't look like electric field lines around a positive charge, although you got this right, you're going to get 0. You've been warned. Okay? That is why I wanted to do this with you. And the last question thereafter is E-net. Okay? E-net, I want to do this with you. Right? Calculate the magnitude of the electric field at QB at X. So this one I can do. E is equal to KQ all over R squared. which is 9 billion, multiplied by QB is a charge of 2 times 10 to the minus 6, all over R squared, which is 0,6 squared, and you get an answer. Yeah, there it is. You get an answer of 5 exponent 4, 50,000 newtons per coulomb, okay? And now they want you to calculate E net. A second charge A is put there, QB and X. They want you to calculate the net field at X for only 3 marks. Calculate the net field at X for only 3 marks. Look at that. Normally it is 5 marks. Now they dropped it to 3. Your trial exam was 5. So please, now if you look at this, this is a positive charge given positive. What will that positive do to the test charge? Push it to the right with E1. This charge is also positive. Will push the test charge to the right with a force of E2. So what do we know about both E's? Both E's are in the same direction. So E net is equal to E1 plus E2. But there's E1 here, I worked it out. E1 is 5 exponent 4 plus E2. You'll work that out as KQ2 all over R2 squared. And get your answer to be, there it is, yeah. Right? There's E2, 11.02 exponent 4. And if you notice, they're in the same direction. All the vectors are positive. All are positive. And that's your total E to the right. Now, why the examiner hasn't got the direction? Because they asked for magnitude. Okay? They asked for magnitude. And the last answer tried to trick learners. They asked them to calculate the net force. Net force on an electron. And this is the equation, learners. F net, it's in the data sheet, is equal to EQ. You take that E and bring it down. There's it here. There's the E. But you take the charge of an electron, because the examiner asked you the charge of the net force on an electron. So the Q will be the charge of an electron, not the Q's on the top here. Many learners took the Q's from the top here last year when they did this paper. So please watch out for that. The examiner twisted the question and said find Q or find the net force on the electron. So there's the electron's charge. That charge is not there and it's definitely not on the others. But learners, unfortunately I didn't finish question 9, the last one, because of time constraints. I do apologize for that. I will quickly show you the memo for the online learners. Okay? It wasn't that difficult a question. Okay? The ratio of resistances in terms of X less than is the next answer. The resistance in parallel, you have to solve for it. Okay, using EMF and getting 12 ohms. Again, what we can see with these, the mark scheme is decreasing in current electricity. Right? They're absolutely right. We are on time. Ladies and gentlemen, I just hope you do well in your exams. My prayers are with you. Right? Go well, be well, and be smart in the exam, not fast. Be smart. All the best. Right, our online learners, I will finish off. I will just show you the memo for question 8, right, before I leave you. And question 9, which is the mechanical energy in terms of alternating current theory. mechanical energy being converted to electrical, right? And there's the balance of it, 9.4, right? What is the power? There are many options there. The best option is always option 1, right? Thank you, ladies and gentlemen, online as well. May God be with you, and you do the best you possibly can to ace your examinations. Thank you.
So there we go. That's where we leave it off. We must really thank our facilitator for his professionalism and clearly his experience in the field of physics is by far very professional and of a high standard. I wonder if we can get some final remarks from the facilitator about his thoughts. It looks like he's packed up over there. It would have been good to just get some sort of a feel of.
Right?
Well done, Mr. Adiban.
Okay.
Tell me, how was your session today?
Hello, sir. Is it on? Hello, sir.
Yes. Tell me about your experience today, your first online physics session with South Africa at Falaah College. Let us know your thoughts.
Oh, okay. Minimize it. Hello, sir. You can hear me now? Hello, sir.
Yes, I can.
Yeah, no, it went well. I think I just ran short of the time for the last question. But it wasn't a very challenging question anyway. But the main thing was I wanted to look at the mechanics, because if you look at the history of the performance of the learners right throughout, it's the mechanics of the section, question 1 to 6, where they really struggle in the paper. But the latter part of the paper they catch on, because the teachers did a good job. Nationally, I would say the teachers do a good job with electricity. But it's the mechanics, because it's so abstract, that the learners find a lot of difficulty, because it's highly mathematical, very highly mathematical.
Tell me, will we see a few established quantum scientists and pharmacists from your cohort today?
Sorry, I didn't hear that, sir. Come again? A bit noisy.
Would you expect some of the grade 12 learners to become quantum scientists and pharmacists from today's session? I think it was pretty well received.
Look, when I spoke to the audience on the outside, they were actually quite happy and pleased with the session itself. They said, obviously, yesterday I was going a bit fast, because at that moment in time yesterday, remember I had 2 exam papers to finish, which was 6 hours, and but I was only given 4.5, so that's why I was racing a bit. But then when I slowed down and paced it, it worked out well. But the learners, they were very appreciative, because they said there are a lot of things that they missed before that they actually cleared up concepts now. So I guess it's better late than never, sir, I suppose.
Okay. Thank you. Deeply appreciative for your input. There's been lots of requests for physics workshops and assistance in regards to physics. So we are deeply appreciative that you have been a very important part, Mr. Nikesh, of this inaugural physics online workshop. Mathematics and physics are some of the required subjects for careers for the future. Would you agree?
Yeah, for engineering, for example, and med school, it's a must. So, you know what? I am happy all the time. You know, one of my goals is, I always say this in interviews when I'm interviewed, is to empower South African learners to be the best that they can be in the international spectrum in mathematics and physical science. It is one of my biggest goals, and I hope to achieve it someday on a bigger scale, not only on a classroom scale or school scale, but beyond that, because it is immense. The amount of doors that these subjects open for a child's life at 18 is astronomical. I mean, you can go places in seconds like that.
So there we go. We salute your effort. So a very big focus of Awqaf and Al Falah's interventions here around physics and mathematics is to prepare learners for careers in the future. So we are looking at futures. So we are deeply appreciative for your input, and we hope to link up with you for another session, perhaps in the new year, where we can do this on a bigger scale. And yeah, so we definitely look forward to that.
All right, thanks. I really appreciate that. Uh, Obviously, it's a learning curve for me with the electronic media, and I have done broadcasting of lessons before during COVID, when I was actually told to leave school because of my poor health at that time. And so for 4 months when I was at school, at home, I did live transmissions from my house to my learners in my classroom, and I taught them that way. So obviously, this is a more sophisticated system now that I'm using compared to what I used 4 years ago. But I'm glad that things are going ahead with technology, and we in South Africa are catching up to it and excelling at it as well.
So there we go. So we always like to use some of these modern technology and tools to make some of these sessions and assistance to our learners in preparation for the final exam, and also at no cost, because there is quite a cost attached to having private tuition. So yeah, that's where we leave it off. I think I want to call Mr. Catherine. We want to chat to him a little bit. He's been a superstar, him and his team, as well as Khalid, who's been our presenter. So we'll speak to Mr. Catherine and find out what his experience has been like.
Thank you, sir. Appreciate that.
Thank you.
Thank you.
Hasnain, you're too loud here. Hasnain, can you hear me?
I can hear you. Can't see your handsome face.
We just
Okay, so while you get in position, Mr. Catherine has been very busy. The school has hosted a soccer tournament. We've had on Saturday and Sunday. We have had Maths Paper 1, Maths Paper 2, and Mr. Catherine has been providing the support, and he's done an amazing job in him and his team. So we just want to hear some feedback from the man behind the mixing desk and the technical wizard there at Al Falaah College.
thank you very much for those kind words. You always are kind in your compliments and so forth. It was a pleasure to once again work with the team over these 4 days, and especially over these last 2 days, to get to know Mr. Haribanchan from the physics side. It's a first time situation with him, so there was some hand holding at the beginning, but as he got into the process, it went quite smoothly from our side. Technically, I would say it was quite a good broadcast. One or two little snags because we going through some teething issues on the physics side, but we'll iron them out as time goes by.
So there we go, Mr. Catherine. We are doing something very constructive. It's always very challenging, and there's room to improve. So what we've been doing was with Mr. Catherine, like we go with our roadshow across South Africa, we try and provide the support to our learners, to our future generation, but it is dependent on some technical support and technical expertise and lots of late nights and early mornings in terms of settings. So we salute you and your team for your dedication in jointly working to providing quality education in South Africa.
Thank you very much.
Any concluding remarks, Mr.
Well, I think in conclusion, I look forward to the next round of broadcasts, And I really want to compliment Awqaf in the efforts they put in into this sector of education, amongst the other things that you guys do. It's always great to work with the organization, both with the local guys and yourselves in Cape Town. So thank you very much, Shukran, for all your assistance.
Okay, Afwan, thank you.
Okay,
So that's
Afwan,
the
thank you. So
typical
that's the
thing, Mr.
typical thing.
Catholic. Unsung heroes of this. There's lots of early morning setups. There's lots of testing and dry runs that we do behind the scene. And I also like to thank Khalid. He's done an excellent job to keep the conversation going with our online cohort of learners. He's been the presenter. He's been behind the scenes as well. So we just pray that you may continue and rise to great heights. And we're deeply appreciative for your inputs in contributing to the success of this program. All right, so that's where we're going to leave it off over there. Khalid does send his warm regards to one and all. And these videos are hosted on Awqaf's YouTube platform. You can refer back to these sessions. You can use it as part of your revision. Don't forget to subscribe to the Awqaf's YouTube platform as well as our Facebook platform, and do share these videos with your family and friends. That's where we leave it off over here. We're signing off from myself and Khalid. Thank you so much for joining us. You've been an awesome online code of learners. That's where we leave it off.
In the year 2000,